This is the brightest. Yeah. Closer. Well, you guys can see me, right? And hear me? Okay.
Yes.
Yeah, okay, good. Yeah. Well, I checked the video recording from last class and there were no audio breaks. So thankfully, I think it's because it was all recorded locally. So, you know, those of you who missed last lecture or parts of it because of the audio can go to YouTube. It's there. Yeah, today we're gonna do. Are we gonna do pointers? I think we thought we were gonna do pointers today. Yes.
Yeah, you said we would.
Yeah. Okay. Sure. Well, let's think up some interesting things to do with pointers. In the next. Well, usually we start at 8:30, right? We until then we're just shooting the breeze, waiting for. Not shooting the breeze. Important stuff. We're talking about important stuff to do with sometimes a class, exams, and things like that. So you can't really skip it. But yeah, but in general, I assume the class is going okay. Well, this is the wrong set of people to ask, right? It's like asking the people who come to class, is the class good, or are you getting stuff out? What I should be doing is asking the exact same questions to the people who are not coming to class, and I think that was a challenge that I think Debbie, when she was acting chair of our department one time in the past, she was, because we had people who were dropping CS2B, and I think also CS1B and things like that. Some of the more intermediate and advanced courses. And so when we send surveys out, usually the people who respond are the people who are sticking around. And so I think she was, I don't know, she was trying to design a survey or a questionnaire which would have a higher success rate amongst the people who don't come back, which is the greatest challenge, I think, right? I don't know, how do you do that? One thing you can do is, obviously, the guys who are, yeah, I think this is the only way we can actually get the data, right? Because, the staff cannot reach, the faculty cannot reach out to students who've gone. However, the students who've gone are still friends with the students who are still here, right? As amongst the student population, it's a group, and I remember back to my student days, right? So some people enroll in classes, drop classes, and so on. But but we all just get together and talk, and so that would be a great way for faculty to get feedback from the students who've dropped, right? So maybe on your Discord or Slack forums, and you kind of try and get a feel for why is it that some students drop off. Now it's okay, people can drop off for various reasons. One could be basically lack of interest. That's natural. That's great. That's okay, because when the interest returns, you'll also return. The other is because you're enrolled in too many courses. You want to do this later at a good pace when you're able to enjoy it. That's also okay. But I think what's not okay is going away with a bad taste and saying this class is no good. It doesn't work for me. Well, if it doesn't work for you, at least you can still talk to your classmates and say why it doesn't work for you, so that if it's something that can be worked into our class, we can do it. Or we could also give you some feedback on saying, hey, we offer other sections too, right? So this might suit your mode of learning, so you can go there and things like that. So yeah, if you guys who are sticking around, not a whole lot now. I mean, we haven't even started class, right? It's 8:05. You can get a feel and pass the information back to us. But I think on the whole, judging from the pulse of the people who are participating in class and doing the quest and looking at the code that's being submitted and so on, I think there's a good deal of engagement among students, not just the ones who are coming to class, right? Even the ones who are not coming to class, but actually working on the quests and coding and learning. There's actually a great deal of activity, because even if I look at the logs for the axis patterns for Michelosov notes, I see a lot of people actually referring to that material And it's also correlated, right? So you can tell when certain quests are being worked on by students, certain elusive modules are also being hit. So there's these two different systems logging the same kind of related information. So which is all very good. I think that's the way to be. Because let's face it, you only have me for 3 months, right? Because the way this can work is basically just figure out how you can find the information you want in order to do what you want. And if you can, and I can help you along the way and also point you in the right direction. But by the time you leave college, if you've just figured out how to get the information you want, you're basically set, right? You don't need to have a formal teacher anymore. Because the role of the teacher really is to when you say you want to do something or you want to know something, the teacher is basically just going to point you, right? Okay, well, here you go. That's where you can find it, right? So they're not going to say, here you go and eat it, right? So I think and I think that the best things that we can do as students is to basically not pick up the facts or information, but to pick up the meta information in the teaching, which really is here's how you find the information that you want. Now, here's the information you want, but here's how I found the information you want. So every teacher gives you both of those, right? And I think as you become more and more senior in your studentship or in your learning, you tend to place greater emphasis on this rather than that. Saying, well, how did they find this, right? So every time I ask this person, they have the right answer. How did they find it, right? And obviously they're not looking it up. They're not, deferring to authority, or this is not the way that they're giving me the answer. How do they know it, right? And so you start thinking about it. And then after a while, just like any kind of learning, right? So piano or whatever it is, any kind of learning, that thing just basically just bubbles out into your head and say, well, you factor it out and say, well, that's how they're finding the answer. Okay, now you've got the meta information in your head. Now you can go and tackle your problems on your own without this person having to guide you. Yeah. I think this is true in many, many different domains, right? Not just in teaching and computer science. I'm thinking about, some of the ways in which music is taught in India, for example, classical music. I've seen, and I think I've mentioned this in previous classes too, and because I have relatives in the past who've experienced this firsthand, I also know you can be a student of a musical teacher for 15 years, 20 years sometimes, and you don't get a chance to perform in a concert alongside with him or her. Right, so that's the first step, So to become a professional musician or to perform on your own, you have to first be good enough to be, performing alongside one of the your guru, and they don't get a chance. I find out after a long time, the gurus are actually looking for something very specific, not just if you're able to render a composition on your own, right? Then, you can play the Ninth Symphony flawlessly, right? Without looking at the score like that. But they are looking to see if you've got a feel for the contour of the raga and things like that. There's certain places that need to be emphasized to extract maximum pleasure out of, and things like that, which have been, filtered out through ages, millennia. And so once you've got the feel for it, then you don't need a teacher. So you can basically just pick up anything because you know what feels good about it, and then you can just drive in that direction, right? Yeah, see, I'm not a very good driver, but I know some people. So they go to a brand new city and they just rent a car, and they just look at a map once, and you tell them this is where we need to go, and they just go. They have a sense of magnets in their head, right? Saying, well, we need to take a left here. We've gone too far right here, and so on. So they have that in their head, and yeah, that's incredible. Yeah. Yeah. One time in Baltimore, I tried to do that, and I entered the St. Paul, which was one way, the wrong way, and I couldn't figure out how to get out of it. So I just stopped the car and got out. Yeah. Anyway, there's only so much I can do. Keep talking and talking and talking. Okay. So I think you guys should just keep talking and talking and talking. but try and talk something that would be relevant so that people who come late will know that hey, actually if I'd come earlier, I could have listened to this incredible idea that Madison and Alexandria were talking about, right? Which is actually related to a question in the final, right? So I might actually chime in and say, hey, that's really cool, there's going to be a question in the final about that, right? And so the people who came late may have missed it. So yeah, talk as much as you want about anything really, even if you want to talk about the temperature gradient and things like that, and the graph that Hiram was doing on Desmos, all of that really cool stuff, right? So do that. I think today we'll just talk about linked lists, pointers, and then I can disappear for 5 or 10 minutes. You guys want to just talk for 5 or 10 minutes? I can think. Yeah, I'll just go off screen and think about some things that we can do with pointers today. I think yeah, I think we can create some link structures, right? We'll just create singly linked structures for now. Not, singly means, you have a box and then you have only one link going out of it, right? And technically, there's no limit to the number of links you can put inside an object. You can have a billion links in a point, spray paint pointers out of. So you can have a node in a graph that points to a billion other nodes. Yes. So technically, you can have any number. But useful algorithms we have a lot of useful algorithms for tackling structures that have been made with just one pointer going out, or 2 pointers going out, or multiple pointers going out, but certain very restricted kinds of algorithms. So we'll try and think up some interesting things that we can do with those. Right? I think that's fun. I think once you do that, next class, next week, not next class, we can implement a stack using a pointer. Next class, you can implement a stack using a pointer. But next week, so that would be, this is week 10. No, this is 8, 9, yeah, 9, 10, 11, 12. So this is week 9. So next week is week 10. We can do stacks based on pointers. And then week 11, probably even week 10, the end of next week, we can start talking about linked lists, right? This is also your quest number 9. I hope all of you get to quest number 9, and please tell all of your classmates on Discord and Slack and everywhere that they should persevere to get to quest number 9, even if they don't make it before the end of this quarter, and they get a pass from this class, that's fine. Those who do just pass this class with quest number 6, they should just persevere in their own time, at their own pace over the holidays, right? So you got the winter break, and by the time it's 2B time, which is yeah, I think the 3rd of January, 3rd or 5th of January, one of those days, right? So you should be comfortable with linked lists, and also you should try and seriously consider enrolling in 2B. I'm offering, so I arranged with Beta and Ram so that there's only 2 sections of 2B being offered in winter, and they're both my sections. So I think we had a problem this time where some of the students said, I'm going to an easier section, and they swap and switch sections, right, in 2B. And that is why my 2B class also suffered, because it's down to a very small size now. And hey, you can look at the forum, the green forum. There's only a few people talking, right? Usually it's just buzzing with activity. And this time of year, people are just posting graphs and pictures of things they've done and saying, hey, is this cool and stuff like that. You look at the past quarters, it's like that. This week, this. So yeah, so next quarter, yeah, seriously try and enroll in 2B. I'm pretty sure if you just stick around and finish the 2B and the 2C, you'll pretty much be set, right? Anything you want to do in the world of programming later on, you'll just be able to take on, right? Without intimidation, without being overwhelmed. You'll know it's just a calculus. This is a series of steps I need to follow. I will eventually get there, right? But this is a series of, and then you can also make recent choices, saying that, well, there's something that needs to get done. It's a programming task. It's going to give me a certain amount of pleasure when I get there, but this is the amount of effort I need to get there. So you can make a choice and say, well, is it worth it? Is it worth putting in this effort to get that reward at the end? Or do I actually have enough money so I can ask someone else to put in that effort and get the reward only, right? And share a bit of the reward with them. So all those things you can make, right? So until you get to the place where you can actually mentally chart out an entire program, yeah, there may be places that are wrong. That's fine, right? And in fact, what we do is we allow for some decisions to be wrong in our process of molding the product from mush into the finished product. So some of these things are going to be wrong, but you also have a very good, I think, Fermi estimate. So I don't know, you guys have heard of this thing called a Fermi calculation? Have you heard of a Fermi calculation? Right, remind me sometime, because it's a very, very useful skill for mathematicians, computer scientists, humans, right? Very useful skill. It's a quantitative skill. Just you remind me sometime during class when more people are here. I will absolutely, someone please remind me, right? And it's useful for 2A and 2B also. So where was going with that? Damn, we got sidetracked. But you can do this. Yeah, you can do a calculation to find out how much time each of these roadblocks are going to take. So you're going to factor all of that into your head. So because with lots of experience, you know, right? So in many projects, these roadblocks have cost me this much time and this much frustration, right? So all of these add up. So you know, towards until I get to the goal, that I'm going to have that many roadblocks, and you know, each one may have this much frustration built in. So you can actually have a mental picture of how difficult it's going to be to get there, and also the potential payoff at the end. And you can talk about it with other people and see if people can help out and share in the reward and things like that. So the reason choices will become easier. But it's not easy when you're just starting out programming in a new language, because you don't know how much work is involved. And that is the only reason why it's not easy in the beginning, right? Because you can't forecast how much work is involved. And also, you know, interns, newbies, fresh hires, new hires in companies, they don't know how much work is involved in the entire project, right? And you don't expect them to know, right? So, because otherwise you wouldn't hire them as newbie, right? So, so they don't know how much work is involved. So many times they rely on someone else to give them the priorities. So, but you got to let each of these people grow slowly, because you know you got to get comfortable with what you're doing before you can start looking at something around you, right? So and say, okay, well, I know more and more, right? So I'm comfortable with more and more, right? So that's the reason for learning, right? So the whole point for learning is just to be more and more comfortable with the world. And so if you only know that much, you're only comfortable with that much, right? So, but you know, you want to say, I want to be comfortable with a lot more than that, right? So no matter where I go, suppose there's a tsunami or a typhoon yesterday and I got landed in Kansas, right? In the middle of Kansas, I still want to be comfortable there too, right? So I want to know more around me so that no matter where I go, I'll still be comfortable, right? And so that's why knowledge is so useful, utilitarian and useful at the end, I think. So programming wise, I think, yeah, well, it's good to not know a lot, because if on day one in a company you say, I want to know everything, right? I want to know the nuts and bolts of the search engine. I want to know every single, you know, how everything is going on, right? So and millions of lines of code everywhere, and getting the big picture itself is very hard, right? So I remember, yeah. It's just some very large projects, right? So the temptation is high that you want to know everything, because you want to know if is there a point to doing what I'm doing, right? So I get to do the small part of this big project, but I don't even know why I'm doing that. Well, you know it's going to help, but you don't know exactly how it's going to help. And some experimental and so the temptation is really high to know everything around you, but there's a cost associated with it, because when you try and know all these things, you got to sacrifice time spent that would be useful in knowing your own corner of the cave. And I think that time is best spent just knowing your own corner of the cave, inside out, right? So that now you have the luxury of looking outside, right? Before you didn't have the luxury of looking outside. If you didn't have the luxury of looking outside and you're looking outside, you can never look outside with, you know, comfort, right? It's because you haven't even figured out if there's any, you know, demons in your own dark corner of the cave. And if you're looking out there, you still have to be fearful that maybe there's something in here that I haven't seen that's going to, you know, devour me. So the first thing to do is just to be completely secure here and say, well, I know where I am, right? I know that 100%, right? So there's nothing wrong that could happen in this corner of the cave. Now I can start looking at the rest of the cave, right? And then you look with a lot more comfort and say, you know, and security, because you don't have to waste mental cycles in making sure that your basic mechanics are right. Right, so that's, you know, getting absolutely second nature solid with the basic mechanics of a language, right? Not even thinking about many things, right? Pointer manipulation and even lists and even basic algorithms. All of that is so second nature to you that you don't even think about these things. Then you say, I'm secure enough in my knowledge of these things. Now I don't have to worry that every decision I make is going to filter down into this thing, and I have to check these things again, right? No, I only have to filter it down up to here, and I'm good. Oh, my iPad is there too. All right, we'll let it wing. Is it bothering you? Maybe you don't even hear it. Maybe Zoom just filters it out. Okay, all right. So so you can just say, I'm just going to that product, I'm not going to go all the way to making sure that, the bytes align, or, I'm using the right data structures, or, pointers being changed in the right way, memory leaks, right? I don't have to do all of that, because that much I've already done. So I'm really solid, right? Even if something happens there, I'm not going to be worried, because I know how to fix these things. Yeah, I think that is the thing. Once you know your corner of the cave, even if things go wrong, it doesn't mean that things won't go wrong. Yeah, I think that is what it is, right? And you can also correct me if you think not. I think when we say we know something, it's not that we say that we don't know. We say that nothing we don't know is ever going to happen. I think we're just saying that well, I know it enough to say that if something goes wrong, I know how to fix it, right? And I think if we get to that stage with any skill, programming, or ceramics, or acting, or whatever it is, right? So when you get to the stage where you say, something could go wrong here, but I know how I can fix it, then you can devote your 100% of your mental cycles to expanding your radius, rather than, right? Because until you know that you're 100% sure of being able to fix everything in this little circle, you're never going to be able to devote 100% of your cycles to something else. This is 0.01% still saying, okay, well, something could go wrong here, right? So I think so just by growing that circle, that's the best way to do it, right? Because then you can keep on firing on all cylinders, on everywhere you look, you can fire on all cylinders. And then you can only make progress, right? Even though it may be slow, it'll be inexorable, right? It's just going to keep on happening until you die, right? Or until external forces prevent you from doing that. It's going to keep on happening. So, but if you're not firing with all cylinders, there's always a risk that you're basically just, going to hit a limit and stay there, I think. And yeah, and hitting a limit is okay, but except if if you ever happen to be in a place outside of the circle, you haven't figured out a way to get better, to a better place, I think. Yeah, so I think if you get solid with 2B and 2C, I really think I might actually send you a very lucrative contract, right? So I send your way, right? If you just ace all of the quests from 2A to, in fact, I can tell you right now, statistically, I've run this for over a year. I've done questing for over a year now. Only I think I've only less than 2% of all of my students have started at blue and gone all the way to red 9, right? So some of them have gone to red 9, but they started maybe at 2B and 2C, all right? So I've discounted those people, right? So if I'm talking about people who basically started at blue and gone all the way to red 9, is less than 2%. But even the people who actually went all the way up to red 9, in terms of the total number of students I've had, I think is less than 5%, right? So I want every one of you to be that, right? So then, because I'm pretty sure, right? Because you'll be able to do most things, right? You'll be able to create your own questing system, many things, many things you can do, right? A questing system in VR, right? With maybe a new glasses that come out of Snap or Google or something like that, right? Apple VR. So yeah, maybe you can do a questing system that is related, maybe not even computer science, right? Maybe you go on to major in something else and you build something like that, entertaining, challenging, as well as educational system, right? Maybe you build that using VR, because I think that is maybe going to be the next thing, right? So people are going to be immersed in there. So so all of those things you will be set up for, I think. And I think the reason to do any of the C level courses should do, I think, Python, Java, or C++, I think, because I think we all teach exactly the same material, just in different languages, right? Say different languages, because, you go to our Python class or a Java 1C or 3C Python, they're going to be talking to you about, spanning trees and Kruskal's algorithm, and all of that is implemented in that language. Right? I think it's only JavaScript that we don't offer that track, mainly because I think, well, for many reasons. Okay. But the C++ gives you the advantage that there's so little overhead that you're practically programming the CPU, right? And even with Python, I've told you that before. Why? No, I think it's not just for efficiency. So I shouldn't make that case, right? Because I shouldn't say that people use C++ only for efficiency purposes, right? Because technically, it should be possible for a supercomputer or even some of the more sophisticated computers today to take a code in any language, right? So I've written it in Python or even using MIT's brick thing. So I don't know what they call it, some Scratch, right? So some language like that, I could write it like that. And technically, it should be possible to crunch that using an algorithm into the most efficient machine code possible, right? I think it is. At least bring it down to C and apply all the standard optimizations. It'd be very close, very, very close, I think. So, but what is C++? So I don't think it's for the efficiency. I think, is it because of the knowledge that you can drive the engine closer to its heart? No, that again boils down to efficiency, right? I think it's because you can do things in C++ that you cannot in other languages without a great deal of effort. I think that is the reason, right? Because I think at some point in many of the other languages, we want to do certain things well, you can do it inefficiently. So I say we want to do it efficiently. So you pick a library, and that is in C++. Yeah, you can do most things in most languages. Yeah, what is it that makes C++ appealing? So, I mean, I like all languages, but certain things I like to do in C++, right? So why is it? I don't know. All right. I don't think it is just efficiency, okay? I think there must be other factors, not just style or the aesthetics, right? Because I know, like, out of every 10 people who like C++, I'm pretty sure there's at least 5 who hate its aesthetics. So I don't think it's efficiency or aesthetics. There must be some other reason. Or even, laziness, right? Because you say, I only know C++, that's why I'm going to do everything in C++. I don't think that's the reason also, because I know many languages and I think I'm equally comfortable in other languages too, right? So even if I go back, I haven't taught Java in like 2 years now, 3 years now, but I'm pretty sure if I go back to teaching Java, maybe 1 quarter, right? Just get familiar with it, and then it'll just be like I've been teaching it for several years. So, so once it's like swimming, right? Swimming and biking. So I think, so I don't think it is any of that. So something else. So I can feel comfortable with any of these languages, I think, and you'll know, right? Many of you will also know. So you can also noodle this for a while, maybe talk about this on your Slack or Reddit forums. It's an interesting thread, right? So why do I like C++, or you that is, why do I like C? Oh, why do people like C++? Here are some theories, right? And you can think about that. None of it might be right. That's okay, right? The whole point is to just brainstorm and say, why do people like it? And then who knows, right? And someone might say, maybe this is why people like C++, and they just, provide a little snippet of code that, 3 lines of C++ code, and that's it. That's the answer to your question, right? So how cool would that be, right? And maybe someone will take a screenshot of that and post it on Quora and say, why do people like C++? I found this answer on Reddit, on some strange subreddit, and here it is. This is right, and there's 3 lines of code, like that, right? So these kinds of things are interesting and viral, right? People say, what is the most beautiful mathematical equation, right? And that would be, a Quora question. And it'd be 100 answers, and you can see what gets voted most, right? Or what is the shortest and most beautiful program, or interesting things like that. Anyway, so yeah, that's what it is. Yeah, I really hope that all of you will complete to be in. And I've also, started talking to Ram and Bita about potentially just blowing up the class sizes, right? So there's no restriction that I should only teach like, 30 or fewer students every quarter. I don't know. I think that was a holdover from olden days but maybe it applies to other classes. Maybe it applies to certain other classes where you cannot really handle more than a certain number of students in class. But in certain classes, I know, the more the merrier, right? Like English literature and computer science and math and things like that. I think the more the merrier, because, the teacher is basically going to describe something, and then there's just going to be a rich discussion. And, you can even form breakout groups and things like that. So I think, I think that should be a form of delivery that maybe could also be recognized in community colleges. Because there's no reason that, we're investing so much money as, taxpayer money that you and I are paying into developing these incredible resources and paying teachers, right? So there's no reason that should just be restricted to some small number of people. When, if there's costs associated with it, okay, I can understand. But for some of these classes, if there's no cost associated with it, you just basically just open it up and say anyone, anywhere in the world, right? Or on Mars, on the space station, right? Who want to know about something? Yeah, well, it's going to be hard to learn ceramics on the space station, I think. Is it possible to learn ceramics? On a wheel, right? Wheel-based things on a. No, it's going to be really hard. Oh, it's going to be a different kind of skill altogether, right? It's going to be a completely different kind of skill. Throwing a pot on a space station. What we should do is, send our Andy Rubel off to the International Space Station one time. He's a prof in our, art department. He's also got his own studio in Santa Cruz. Yeah, so that'd be interesting. I should talk to him and say, hey, Andy, what do you think it's going to be like? Spinning a wheel, like, making a pot on not on Mars, on the space station when there's no gravity, right? So they're not spinning, and you don't have simulated gravity and everything. So it's like stationary. So you'll still get the effect of the rotation. So the pot will go out, but there's no gravity trying to push it down. So I don't know how that's going to happen. Yeah, but I think you'll still be able to make hollow shapes, but the vertical displacement has got to be controlled in a different way completely, I think. Or maybe you just have to get a completely different feel for it, right? Feel for, all your nerves have got to be recalibrated now, right? To say, this is not the normal amount of pressure I need to feel for that curve, right? So everything has to be recalibrated. It'll make an interesting discussion anyway. So yeah, you can talk about these things, right? So you can say, what is it that makes C++ interesting? Other than the fact utilitarian, saying there's all these libraries out there, right, that you can only do in C++, right? So, or if you want to program the Unreal Engine, you can only do it in C++. That's why I need to learn C++. No, I know those are also not the reasons I'm looking for, right? So talk about some random project and say, well, you have a number of choices, but for certain projects, people will not automatically pick C++. And if the reason is not motivated by efficiency or aesthetics, what could it be motivated by, right? So I'm pretty sure there's a bunch of projects like that. Just can't put my finger on one right now. Anyway, so it's 8:30. Imagine that, right? Nobody talked. Absolutely nobody talked for the last half hour. And well, partly because maybe I didn't let anybody talk, right? So, but if you guys want to talk, you want me 5 minutes? If you want off your own time, I give you 5 minutes, and then we can start talking about pointers after that, right? Okay. And yeah, I think I have a couple of good ideas for what we can do today. I'm pretty sure we'll get to at least 2 of those ideas today, right? So we'll create some link structures and do that. But I'll let you talk 5 minutes, okay? So I'll be around here, okay? So and just call me. Okay. Is that okay? All right. Hey, Fernando, are you here now? Fernando? All right. Okay, Fernando. Madison, you're here, I think.
Yeah, I'm here.
You're here. Yeah, Fernando. Okay, well, he is here because sometimes he just speaks up. But I got to tell people that just have to take breaks. Time your breaks, okay? So you got to make sure that you don't leave during some critical part of the discussion, and then when you're back, you will find it really hard to catch up. So if you want to take a break, you got to make sure that it's short, and or if it's a phone, you should at least be listening to it, right? While you're peeing, you should just be at least listening to the conversation that's happening. Okay, so you won't lose track of what the hell is going on, and then you come back, and then that is a point where many people will drop off lectures. Okay, when you feel that you've dropped out of the race, there's no point in catching up. You'll say, I'm going home, right? So don't take that risk. Okay, I'm going to step off screen for, I don't know, 5 minutes, but I'll be back as soon as you call me, even if it's 1 minute later, but I'll be back at 8:40. And at 8:40, what we'll do is try, one of you can take the screen, and then we'll code it up. Well, we'll code it up. We'll code up a class. We'll code up a class with a pointer in it, and then we'll code up a bunch of objects of that class and have the pointer point to each other, right? So that we create a link of objects, and we'll try and traverse that link and say, hey, what's the first guy? What's the third guy? What's the fifth guy? And then also we can do a linear search of that link, right? So if you have like you had the vector of 1 million elements or 100,000 elements, you can have a linked list of 100,000 elements. And then you could also have linear search V1 over array, linear search V1 over linked list, right? Two functions, right? They're both going to search over 100,000 elements, except the first case, the 100,000 elements are in a vector. In the second case, the 100,000 elements are in a linked list. And they're both going to be linear in time. So why would one pick one over the other, right? And if you time them, what the hell is going to happen? Right? Is one going to be right? Because previously we knew that we're going to pick binary search over linear search because binary is like a hell of a lot faster, right? But now we got two searches and they're both linear. We're searching a vector and searching a linked list, they're both linear. So why would you pick one over the other, right? So that's a really cool question to ask and answer. Yeah, that's really cool, right? Maybe we can do that today, right? We can do that. So some of the other things that I thought about was one of it was that. Trying to experiment to say, why do we pick, what is the advantage of using a vector? What is the advantage of using a linked list, right? The way I position my fingers probably gives you an idea. The vector is going to be a whole lot faster than a linked list, right? And less overhead too, obviously. Actually, not necessarily less overhead, less computational overhead, but more storage overhead. No, actually, not even more storage overhead. It's a different kind of overhead, right? We'll talk about that, right? We'll talk about the advantages and disadvantages of storing your data either in a linked list or a vector after you've had a chance to play with it, right? Because after you have a chance to play with it, you'll discover yourself the advantages and disadvantages of the two. Then if we start talking about what are the advantages and disadvantages, I don't have to tell you, right? Because you would already know most of, why you should. So that would be great. So let's do the timing. The second thing that I was thinking about was, what if you had a long chain of items and obviously inserting things into random places inside of the chain, we're going to do, right? I'm not even thinking about that. That's basic, right? So I'm thinking about interesting things after all that, right? So if you have a long chain of items, suppose you want to find the 7th item in the list, how would you do it? So you can start here, set up a counter, and go next.
Can you do it in constant time, or you have to go?
So can you do it in constant time if it was a vector?
Yeah.
Okay. So all right. So you'll find out if is there a clever way to do it in constant time if it was a linked list, right? So I can tell you the answer. I don't know. Let's say. So we're going to find out together. Okay. So we're going to find out. So what if you want to get the 7th item? Can you do it in constant time? Now here's that is easy, right? That is the easy thing. But the real interesting question is if you want to get the 7th item from the end, or you don't know how big the list is, right? So the list might be 100,000 items because with the vector, vector.size will tell you how big the vector is, right? But we're not using the standard libraries linked list because the standard library linked list has a size member. It keeps count, right? So if suppose you built your own linked list, right, which doesn't have a size member that you're going to keep constantly updating, right? And now you just have a linked list, meaning here's a list and I give you one node, right? And so here's a necklace and I give you one bead, okay? And I tell you that's a necklace and you trust me. Then that bead is connected to another bead, yes? Right, so that the necklace means, beads are going to be connected, lots and lots of beads, okay? So I say, here's a linked list and I give you one node, okay? Then that node is going to be connected to another node and that node is going to be connected. So there's a whole lot of nodes, but I didn't tell you how big the list is. No, it could be like 5 items long. It could be 1 item long, right? Or it could be like 1 trillion items long. You don't know. So how do you find out what is the 7th item from that end, not this end, okay? From that end. Well, obviously it's going to be linear, but can you make it better than linear, right? So that is the interesting question. And here is the even more interesting. So suppose we get past that, okay? This is going to be hard. I think this is more 2B level. This challenge will be more 2B level, so let's not spend too much time on it. Suppose I have this long chain, okay, long bead, and I took one end of the bead, okay, one end of the bead. So I'm holding on to that end, right? Holding on to this end, and I took the other end of the necklace, okay, and wrapped it around and connected it somewhere in the middle, okay? So what I've got here is basically a loop like that, right? But you don't know where the last node is connecting to. So some node in here has got two people pointing to it, right? The last guy is pointing to it as well as the guy before it is pointing to it. So some node in there, you don't know which one. So how do you know? How do you know which node has two people pointing to it? How do you know? You don't know, right? Because each guy only has one pointer pointing to the next guy. Next. So this guy points to next guy, next guy, next guy, right? So that last guy is pointing to this guy. Right? But this guy is not the first guy, right? This guy is being pointed to by someone else. So this guy has got two people pointing to him. Yes or no? Okay. So now if I asked you, what is the length of the list, right? How do you find the length of the list? You start at the beginning and you keep jumping beads until you get to the end. And then you say, okay, I've jumped like 75 times. So the length of the list is 75. Yes or no? Okay. So that's how you find the end. And that's how you find the length of the list. Suppose I give you a list with a loop in it and say, hey, okay, go on. Now you're bothering me too much. Here's a list. Go and find the length. Okay. And I give you a list with a loop in it. Okay. So that's a good way to keep some bothersome non-mathematical person occupied, right? So you just give them a little loop with 5 nodes and the nodes are pointing to each other. They're never going to return to you and you're going to keep hopping around in a circle, right? Because, they're stuck in a loop, like an infinite loop. They can't get out of it. So how do you know that there is a, one guy with 2 people pointing to it? Because if you have 2 people pointing to it, that's a loop, right? So how do you know? How do you know that? That's a really challenging problem. It takes and it's not a problem that you can just solve in one sitting. If you can't see the solution to that problem, the best thing to do is just think about the problem and just forget about it. Not forget overtly, but start doing other things like, cooking or cleaning or, walking, stuff like that, or biking out there. Because what happens is that if you're, because this is not a problem that has, it is a problem that the solution will just have to strike you, bam, like that. Okay, and say, wow, that's why I can find out how I can find. That's how I can find out if there's one guy has got 2 people pointing to it without using like a billion storage item. Because technically you can do it, right? You can build a huge hash table, huge vector saying that's the first address, that's the second address, and so on. Every pointer I encounter, I just need to check if that's already been seen, right? If that's already been seen, I can't, then 2 people are pointing to the same thing. But that's not scalable, right? So if I have like a 10 trillion nodes, I can have a vector of 10 trillion items. And plus I have to search the vector too, right? It's a thing. So you got to figure out a clever way. And basically clever ways, sometimes are also beautiful ways, but the clever ways don't just come to you by grinding, right? Is it mashing the button? Clever ways don't come by mashing the button. Grinding, you just have to let it lie. It's like a seed. You have to let it lie and water it, and suddenly it'll just sprout, bam, like that, right? And it's not just like you know the solution without, is as though it's like a gift that just appeared out of the blue. No, once you know the solution, you also know how to derive it. So oh, that's why, right? So the flash of insight saying that's why I can find the length or the loop or the starting point of the loop. That dawns on you, right? Not saying, because otherwise you can say, well, someone else found out, and applying this algorithm, I can find the loop, right? Yeah, okay. So you understand someone else's algorithm, but the flash, you would have missed the flash. And I think the flash is really pleasant and pleasurable to have. So, especially since someone is not paying you, right? If someone says, you got to solve this problem in 24 hours because the fate of the company is riding on it, right? Then it's okay. Then, or if someone says, unless you solve this problem, we're going to shoot you, right? Then okay, it makes sense to say, all right, I'm going to search up the internet and find out someone else's solution and I'm going to adapt it. That's okay. But if you're in a situation where it's not life and death, right? Or if you don't have huge stakes riding on it, then you have the luxury that many people fail to exploit, right? The luxury is not looking up the solution, right? Many people will fail to exploit that, even for simple puzzles that they can't find the answer. They have the luxury of taking 100 years to find the answer, but they will just give up the luxury and say, well, tell me how you do it, right? Yeah, and I've also obviously not like, I've also felt the temptation very strongly many times, maybe even now, sometimes I may feel it, right? So, but I think what happens is that I realized that it was a luxury. I think that previously I didn't realize it was a luxury. I just thought that getting the answer sooner basically gets you to the end faster. But really, there is no end. The fun is really in getting the answer. And if you got someone else's answer, then someone else had the fun. And so once we find out that's the luxury you're giving up, then you say, well, you know, you want to ask as little as possible. So you want to basically depend on others as little as possible for your life, so that you can just carry on without having to ask for solutions and find solutions on your own, right? Only things that need to be answered by others to keep you alive, or, you know, keep you reasonably comfortable, need to be asked, I think. So yeah, I think that's why many people also fall into the illusion of grades, right? People think 2A, 2B, we need to get A, we need to get A+. And, you know, even getting from A to A+, and they place so much value on it. That's all total nonsense, right? None of that really matters, right? And you think that I'm telling you nonsense because you're a student and I'm a teacher, and you know, there's so many years between me and you, right? But that's not true, right? Because I can remember so many things, you know, as when I was a student and things. It totally doesn't, the amount of weight that you give to it, you're not going to think about this, right? You're not going to think about this course in 10 years time and say, I got an A there, that mattered, right? Or even the fact that, you know, that A laid the foundation for getting somewhere else, that's all total useless, right? Even the fact that you went to some place that you idolized, that's all totally useless too eventually, right? So you'll see that, you know, what mattered was, you know, the joy you got out of learning these interesting and cool things. So I think that's where we're driving with all of this. Oh, by the way, I shouldn't be taking up any more of your time. So these are the things that we want to do, right? So those are the 3 problems. Hopefully we'll have time to touch upon that loop thing, right? If not, think about it. There is actually a challenge, I think, or a quest. Oh, sorry, it's not a quest. It's not a quest. It is, before I did the quests, I did some of these interesting problems as just spec sheets, and I think this was called, so then you can Google my name and go to my old homepage on Foothill, and under programming challenges, I think this is called Intersect. I think it was called Intersect, INNERSECT, right? I think it was basically a spec sheet, you know, PDF document that says this is the problem, can you solve it? And this is a sample code in C++, and you got to fill in the to-do part. I think that's what I did. That was a long time before I started doing, a long time meaning, you know, more than 2 years ago that I did those. So yeah, I think that's interesting. But that was 2B, definitely 2B. Right. So you can Google that and try that and play with that code too. But that's what we were trying. If we have time, we'll talk about that. Otherwise, we'll try and figure out interesting ways, clever ways. Not me, right? You guys can figure out interesting, clever ways of getting to, and I'll give you hints, right? Of getting to the nth item from the end, right? Nth item from the end. And I'll try and think of other problems like that too, right? And also next class for stacks, think of some interesting stack-based problems. Okay, we'll try and solve those stack-based problems too. So as stack-based puzzles, right? Not puzzles meaning problems that don't have explicit solutions, but, you know, tricky, interesting solutions, right? That we can figure out. How do you take one stack and invert it, right? And things like that. All right. So did you guys want 5 minutes? We'll start at 8:55. You guys can start coding at 8:55. We'll have an entire hour of coding, right? And one of you can start coding, and then we can go from there. Is that okay? 5 minutes? All right. I'm going to be around, so you can just call me, right? If you need me to answer anything. All right. Thanks.
Hey guys.
Hi.
I'll have to go soon. I'm in the office today.
Yeah, I also have to go soon.
Uh-oh, I wonder who's coding. It's gonna be the other Madison or Hiram, probably.
Yeah, I'm super sick.
Really?
So,
I'm sorry.
yeah, I work a retail job, so some kid got me sick. So
It's awful.
yeah,
That sucks. I'm sorry.
I'm doing my best to stay awake for class, though.
Yeah, that's rough.
Yeah.
Imagine coding like publicly while you're that sick.
Yeah.
Oh god.
Yeah, that would be embarrassing, I think.
Yeah.
Yeah. Did you guys check out the graphs?
Yeah, I did, and I like actually copied your idea for like running the binary one 1,000 times more than the
Did
linear one.
it work
And
for you?
it worked for me. Like also like your linear graph like looked really weird, right? Like it had the curve like a
It looks
logarithm.
really weird. It looks like a
When
curve.
I did it, it looked perfectly straight. So I don't know
Oh,
what happened
good.
for you.
Okay.
And then
Yeah,
I
it
did
might
it with the 2 times. It took like 2 hours to run.
2 hours. Oh,
Yeah,
I didn't do
yeah,
it that many times.
yeah. It took 2 hours for me.
But
But
didn't the binary search looked really clean?
the binary was, yeah, yeah. Actually, for me, you know how you had that little like bend up at the end? I had
Yeah.
the same thing, but more extreme. I think it might be like, because I also went a little further into the size.
Oh, so
I think
yours
I went
is
until
more
six.
accurate.
I think I went until 16 million things in the array. So yeah, and the curve kept getting more up after that. So it would go like logarithmic, and then suddenly it would start doing like a little
Really?
bit less logarithmic. I don't know why.
Yeah, that's weird.
Yeah, I
Like
saved it
I
in.
tried to speculate on why it doesn't fit, but I have no idea.
Uh, yeah, like until um until like 400,000 things in the array, it was like less than 2.5, and then suddenly it jumped to 3.5, then 4.5, then 5.7, then 5, and then 6. Like it was crazy.
You mean seconds, right?
No, like sorry, 6. 6 times 10 to the negative 7. All of those were times 10 to
Oh,
the negative 7
okay.
per run, per run.
Gotcha.
Yeah.
That's pretty cool.
Yeah.
Yeah, it was worth doing.
Yeah, it was a really cool experiment. Of course, I don't know where my code differentiated from yours because I wrote it all myself. I didn't copy yours. So
Well,
I
as
don't,
long as the searches worked, then it
right? They
should be
both,
the
I'm
same.
pretty sure, yeah, the searches were pretty much identical. So
Yeah, so it was, I don't know. All right,
know.
guys, I've got to go. Have fun with the pointers.
Bye.
Bye, guys.
I
Okay. What are we going to use pages for? It's interesting.
Hey guys, so wow, okay, well, I got to come back sooner because there's so much silence here. As long as there's voices, oh, yeah, none. What's the word for? What's the corresponding word for video? No video, right? So no sound is mute, right? So no video, I don't know what that is. Blind. Yeah. So yeah, I think that's the corresponding word, right? So mute and then no, but blind is got other. It's got the opposite connotation. You can't. Oh yeah, you got to blind the camera. Okay. Because you're muting the microphone and blind the camera. Okay. Are you guys still here? Hey, Alexandria. Where's Alexandria?
She said that she had to go. She's in the office.
Oh, she is? Okay, well, I don't know. Who's gonna code? Who's gonna code? I know, Madison, you can't code. You said you have a sketchy connection.
Yeah, I come in
I
a
know
lot.
Hiram is looking like, yeah, like he's throwing up his hands. Unless Maddie wants to go, right? Oh, Fernando, if Fernando's back and he wants to take the screen, this would be like great opportunity, Fernando, right? So you get to create an object, you get to create a pointer to an object, you get to talk about classes and connect things together. It's like so cool. This is a cool thing to do. Do you want to take that opportunity?
The thing
Fernando,
is,
are you here?
yeah, I don't have my computer with me. I'm using my phone with me.
Yeah, so you said the same thing last time too. You got to make sure. Why don't you go to the STEM Center? You got so many free iMacs there to use.
It's because I'm in Yosemite. I came with my family here, and I don't have my computer with me. I only got my phone with me.
Oh, so no, I see. But you know you can go to the campus, right? You can go to campus and use one of the top of the line computers to do this thing.
Yeah.
Are you far away from campus?
I'm in 3 hours away.
How long away?
3 hours.
Oh, 3 hours. Wow.
Yeah.
Okay, well, you got to figure out some way in which you can get a computer and code. Okay,
Yeah,
otherwise it's going to be really, really hard.
Yeah, I'm coming back on Wednesday, tomorrow at night.
Can you code? Can you try and practice a little bit and code? I'm going to help you. Everybody's going to help you. What about Thursday? Can you code on Thursday?
Yeah, that's okay.
All right. Okay. So try and plan to do that. If you're feeling a little antsy about it, just get in touch with me on Wednesday or something by email, and then we'll work something out. We'll try and say, set up ease you in and so on. We can work on these things. Okay.
Yeah, that's okay.
All right. Good.
Thank you.
So Hiram, yeah. Okay. Hey, Maddie, do you want to code? You don't look so well.
Yeah, I would, but
Your eyes are like half shut already.
I'm really sick right now.
Why you're welcome. Just show close your eyes and just listen, and I think that you'll be fine.
Okay, thank you.
Time to take a snapshot of the code that Hiram is going to code. All right.
Thanks.
Are you
Thanks.
Should I do it?
Or-
Yeah, should I do it in my Linux or should I do it in like online GDB or Replit?
Actually, you know what? If you do it on Replit, you can share it. I think.
Okay. Yeah, I can do it on Replit.
Online GDB too. I think people have shared in the past.
Before we get started, I have to leave in a few minutes, so I don't. I'm saying that now, so I don't just drop out without a word.
Yeah, sure. Can you just keep listening to us while you're off, or you can't listen to us?
I have like one day I have a very special meeting. Like
How long?
Like
How long?
won't happen again, but it's a one-time thing that's happening right now.
No. Is it 5 minutes or 10 minutes or 2 hours, something like that?
Yeah, it's like a full thing.
Oh, is it? Okay. All right. Good.
Yeah.
So you're gonna basically take off now.
Yeah, I can stick around like 3 minutes or so, but
Hey, no worries. No, I'm not too concerned about. I'm not concerned about you, but I know you've completed quest 9.
yeah.
Yeah. Okay. So you don't really need to sit through this class. So thank you so much for just coming by.
Yeah.
Yeah. All right. Good. And you can always watch the video later if you want. Okay. All right, Madison, you can take off if you want. All right. So that means
All
it'll be like and Maddie's going to be participating with eyes shut, eyes wide shut. Okay. So, and Fernando has got a phone. So it's just basically one-on-one class with Hiram today. All right. So there you go. Cool. So Hiram, just let's do it in.
Okay. Yeah, I have that set up.
Oh, you got to share your screen.
Yeah.
And what we'll do is start up a blank project, and then we'll create a dummy class called Node. We shouldn't choose. Yeah, we'll just, this is traditional name, right? Traditional. You can choose any name you want. We'll call it Node. right on top of main. Yeah, actually, let's do it the proper way, right? Node.cpp, thank you. And call it capital N because it's going to be a class def. Capital node.cpp, yeah. Right, now let's go in there. Shall we do it the regular way? Node.h also. Let's create node.h, which is where our class def is going to be, right? Okay, let's go to node.h. Is everybody comfortable with what we're doing? Yeah. Right. So here, open a comment. Say we're going to define a node, a class. We will define a class called node, and it is a single data item which points to another data item just like it. That stores the address of, and then within parentheses you can say points to. So people already looking at this code will know. Oh, we're going to be talking about pointers today. Yeah, a single data item that contains let's say an integer. Let's say an integer that contains an integer and a pointer, and the address of, and then we can say a pointer to, and the address of, and within parentheses you can say in pointer to. Another data item exactly like this, except with a different integer and a different pointer, except with a different integer and a different pointer. Hopefully, just by reading this comment, we should know, right, what it's supposed to do. Yeah. Okay. All right. So let's create a class. Let's create a class. Class node and capital node. Yeah. No. In what language do we do a colon? In some language, maybe we do a colon after the class def.
Yeah, I was messing it up. Yeah, I messed up.
Oh, I see. But is there a language in which we put a colon after the class def? Is it Python? I forget.
Maybe, I don't remember. I just messed up.
Anyway, never mind. Okay, public, and let's say let's make them all private so that we'll create getters and setters. So under private, say int data item, int data under say int data. Not even size t. Say let's say int data. Okay, let's go. And then what we want to do, this is the clever part, okay? Now, if you have a node, and you have to answer me, okay? If I have a node, and I want that node to be a recursive data structure, which means I want this node to contain another node. So if I want this node to contain another node, is that possible? Is it technically possible to do that? If I want a node to contain another node, is it possible?
I bet you.
So one way we may think that we can do it is by saying node, another node. So just say node, space, another node. No, we may think that it's possible to do it like this. Yes? Yes or no? So put a semicolon after the class def so that we know it's a complete class now. Right? No, after the class def, after the last, yeah, there you go. So it's really a complete class, but there's a problem with this class. So what is the problem with this? Why can't we do it like this? Structurally, think structurally, right? If you're an engineer building a castle that needed to have another castle inside of that.
Yeah.
Right? So it's not possible, isn't it? Because you cannot have a whole node inside of a node and have space for something else too. Yes, you can have a castle, an identical castle inside a castle, and have room for people in that. Yes or no? I don't know. I'm not getting any feedback.
That makes sense.
Well, Maddie coughed, so maybe, or sneezed, so maybe that's a yes. All right, there you go. But so you cannot have a node inside of another node without occupying the entire space. So, however, it is possible to have a node and a piece of paper that says there's another node just like this, but it lives like 5 miles away. That's possible, yes?
Yeah. Totally.
Yeah, okay, so there's two things. One is not possible and the other is possible, right? So you cannot have an object of the same class inside the same object. It's not even conceivable mentally, right? Because we don't yet have a mathematical model for infinite recursion. right? Technically, it should be possible to develop a field in mathematics in which, there's a recursive kind of infinity, which is different from the iterative infinity. So you can develop an entire field of we don't want to leverage any of that, or at least I'm not aware of a field that has been developed like that. So we're going to say that's not possible at all. Not in the universe that we're used to. We can't have a node inside another node. However, we can have the address of a node in a node. That way we can have the exact same effect, effect that we wanted. However, it's feasible because now I just need to know. So here, the way we're going to do that is by saying node space, right? Yeah, node space. What asterisk? This star, right? And say node P. No, say another node P. Or you say node P, right? Another node P. In fact, you say another node P, because just to say, because the previous comment said another node. Okay, so now that is you can put a comment there that's saying this is the syntax for saying another node P is the address of an object which is the same as this node. We can actually go on to the next line, I suppose, right? Yeah. Yeah, another node, and you can say AKA a pointer to a node, right? Within parentheses, however you want to do it. A pointer to another node. To a well, whatever you wanted to say. Let's get rid of the underscore between another and node, because we had tried to do a variable called another node before, right? So this is actually another node. So does this make sense to everyone? This is how we create a link, right? This is we've just created one bead in that necklace, but that's all we need to know how to do, right? Well, we need to know a few things, how to manipulate the beads, but this is a basic structure, right? Now what we can do is go into the public part, and first let's do some getters, constant getters that are basically just going to return the get data and get next, get data and get next. Call them get data and get next. So you're going to say int get data const. This is a const go after.
It goes after.
Yeah. Const, and then you can just return right there on the same line. You can just say.
Oh, right, yeah.
Just inline one line. Okay, so that's really cool. All right, and then likewise for the next, get next, int get next. Yeah. No, node star get next, because it's going to return a pointer to the next node, right? So node star get next. Is everybody okay with this so far? Fernando, are you okay with this? Fernando, you can't take off like this, okay? This is all important stuff, because you're going to be struggling. Because if you take off like 5 minutes here, you're going to be spending like 50 minutes later. And why lose out on free stuff like this? Okay, all right. All right, so is everybody okay so far? Okay. Now what we want to do is do the important things, like we want to set the data and get the data on a node, right? So we want to do setters. So let's say you want to do 2 setters. In fact, put the setters after the getters, because the setters are sometimes not trivial, right? Getters are trivial. The setters may not be trivial. So yeah. So you can say void. No, it's just a bool set data. In fact, I don't even know if it makes sense to have a bool, right? Because if you're going to set an integer, and how can you fail setting an integer? If you set an unsigned, you can fail, right? If I say set unsigned value and I pass you a negative number or something like that, and you can say no, it's not. But integer, you don't have anything, so you just say void. Yeah, void set data. Void, but it's going to take a parameter saying int item, int item. In fact, you can say data. I'll show you how to do that. Okay, say data, int data, right? Now, data has 2 meanings now. Data is also the member of the object, and data is also the name of the parameter. How can you tell the compiler which one to use when you assign to data? Right. So the way we do that is, this arrow. You can say this arrow data, which means the data object that is attached to the object, the data item that's attached to this object is equal to just the plain data, which is the data that was passed in as a parameter. Okay, so that's very, and sometimes it's you got to be very used to programming before you're comfortable with this. So what many people do is, instead of calling the parameter data, they'll call it d underscore data, right? So it's all very clear, and they don't have to use this arrow, right? So sometimes you can say d underscore data. Instead of int data, you can say int d underscore data, and then you don't have to say You don't have to say this arrow data. You can just say, does it make sense? You can do it either way, but there's two different ways that people usually do it, right? You don't have to say D, but it just has to be different from data. You can even call it D if you want, right? Because it's just one line, everybody will know. Okay, yeah, up to you, up to you. Yeah, okay. Now, now let's do the next, right? Set next, right? Set next, right? Set next. Set next also, because it just needs to be, let's say, all right, make this bool, okay? Make this bool. I'm just, yeah, make this bool and put a blank line before that, and we'll put a comment also, right? Yeah. So our next setter will not let people set a null pointer, right? Because if you set a null pointer to a node, you can basically accidentally truncate the list. Yes. If you got a bunch of nodes pointing to the next item, and you go all of a sudden to a middle node and say your next item is not the next guy anymore, it's null, right? Your list ends right there. What happens to all these guys? They don't have anyone leading into them, so they're all lost. They're just dangling in space, like filaments, just floating around in space. Yeah, lost. So so we're going to say our next setter will not allow setting a null pointer. So you're going to say set next is going to take a node star p, yeah, and usually put the star next to the p because it's there's a reason why the star is put next to the p rather than next after the node, because I've seen lots and lots of programmers and even code out there where the pointer, the star, is attached to the type and not to the variable, right? And you know, you go on Stack Overflow and you see people talking religiously about this. There's no reason you can't do it either way, but here's a reason why I think it makes more sense to attach it to the variable and not the type. Okay, so if you have multiple variables of the pointer type, right, then you know node star ABC, right? So node star ABC will be interpreted differently by the compiler. It will look at node star A, right, and the next one is going to be node B, node C. So the next two are not pointers, but you attach the star to the node star, but the compiler didn't attach the star to the node star. The compiler attached the star to the A. Does that make sense?
Yeah.
Okay, so that is the reason why I think it's beneficial to attach the star to the variable. The same thing with, I think the same thing goes for references also, right? We should experiment and find out. But if you attach it to the variable, it means that, you know, this is a reference or a pointer to that type, not that, you know, this is a variable of a pointer, because there is no variable of node star, really. As far as the C++ compiler is concerned, all it knows is just a pointer. Right? It doesn't know it's a pointer of this particular type and things like that, right? Actually, well, it does, but I think in a slightly different sense. Well, let's just forget I said that, okay? So, yeah. So, all right, notes. So you're right here, you're going to say if P equals null, return false. If P, yeah, double equals, and yeah, null. And some people also use another C++ alias for null, which is nullptr in all lowercase. That also works. Okay, I think they're both alias to the same thing, but null ptr is more readable because you know it's a pointer and not a null character. Null character is just 0, right? Used to terminate a string, so you know it's not that. So null ptr. Okay, now you know it's not a null pointer. You can say this arrow next another whatever that thing is called, right? Or you can just say another pointer P, or what did you call it? Another node P? Yeah. All right, return true.
Oh, right.
Now, this is very simple, right? We're just going to go one level higher from here, right? It's slightly more difficult. We've seen how to set a value. We've seen how to get a value. Now we wanted to know how to insert a value, right? This is the most challenging part, okay? So how much time do we have now? Once you, we've got a lot of time. So once you know how to insert a value into a list, that, you know, it's not 100% of how to manipulate a list, but it is one of the most challenging operations for a newbie, right? So if you've never played with linked lists before, getting to be comfortable with inserting and pulling values out of a list is like super, super critical. If you're comfortable with that, you can just play around with the list. You can just play around. You can see all these jugglers like juggling 10 balls, bam, bam, like that. Okay. It becomes like that because once you get, and you know, they started out with 3 balls, and I've seen, so my neighbor, when I was in the SRI lab, he used to juggle, and I think, and his neighbor upstairs was a juggler and a unicyclist, right? So I used to talk to them, and I said the most challenging part is learning to juggle 3 balls. Okay, so once you get to know how to juggle 3 balls, you can easily adjust for any number of balls after that. I think up to a certain threshold anyway. So like that, I think this is like the biggest part. Once you know how to manipulate these pointers in your local neighborhood, right? Meaning that here's my necklace and a new beat is coming and I need to slot it in here. Okay. Once you know how to do that, you're good. Okay. 90% of the way in. Okay. And someone says, give me the 7th beat out there. You pull it out of there and give it to me. And you know how to do that. You can go in there and pull out exactly that beat without much collateral damage. Okay. So, you say, I want that beat, and someone will go there with a pickaxe and bam, 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 shatter everything and give you that one beat. No, that's not the way to do it. If you can go in like a surgeon, right? And say, you want that beat, I'll get you that, with none of the other people even knowing, right? Just making those cuts and joining and you get that beat. So once you're comfortable with these two, you can just basically play around with lists, because after that, you're not even thinking about these low-level manipulations. You're thinking about algorithms, not even using traditional terminology like this. You're thinking about algorithms like you're thinking of filaments floating in space, right? And thinking of, if there are these filaments and I want to solve this problem among these linked structures, right? How do I do that, right? So you can boil things down from that level all the way down to the level of bits and bytes, right? Through these operations. But once you get comfortable with these basic things, right? And after that is, once you get to that stage, it ceases to be a matter of routine mastery of algorithms like that. After that, it just becomes clever strokes of luck. Okay, so that's why all these brilliant algorithms you see out there. Many of them many of them were born in just strokes of luck, right? When it's not like they just realize that and hey, it works, right? And but sometimes you also get to it by through the grind. But many algorithms, they just have a gut feel, or test it out and it works, and then just refine it and then work backwards, right? Like mathematical induction, get the proof and then work backwards to the first principles and show that it's true, right? And so lots of algorithms born like that. And that's because people don't usually think about solving a problem, or not always algorithmically, right? They're thinking about this, vividly, pictorially, filament space, floating in space, and they say, oh, that's how I can untangle this bunch, okay? And then they'll try it out and it works. But in order to do that, I think getting familiar with these basic operations will work. Okay, so the next thing we're going to do is, try and insert an element into a random position in the list, okay? So let's say we want to create a method called insert an item. No,
Would this be main?
Let's do it in node.h itself, here, right here.
Okay.
I will declare the method. We'll declare the method and we can implement it elsewhere if you want. Okay. So let's declare a method after set next. Now you can say bool insert new item, bool insert new item. I think, right? I think that makes a reasonable signature. Okay. And then you say int space data, because the item you want to insert is the data. Yeah. And then you also need to pass one more parameter, which is a place where you want to insert so here's a long list, right? And I want you to, it shouldn't be I'm so sorry. It shouldn't be a node method. It should be part of the link list method. So let's get it out of there. Let's get that.
That's what I thought. Okay.
Yeah.
So do we need to make a new class?
I think so, right? So that I think, is that good? Yeah, you want to make a list also right now?
I don't know.
Let's not make a list. We'll play with the list. And what we'll do is we'll go to main and then use a node structure and play with it, right? Because all we need is just a node now. Let's not worry about the list. You're going to implement a list anyway in quest 9. Yes? Yep. So what we'll do is play with a single bead. Okay, we've got a node that we've created. Now we're going to, in our main, we're going to create lots and lots of necklaces using many beads and play with these necklaces, because that is the core of the list. That's what we want to master. We want to go get rid of everything, all the fluff around the list. Let's go right to the core of the list and see, that's the chain. We want to play with the chain. Once you're comfortable with the chain, you can wrap it around with any kind of ice, icing. You can make Is that okay with you guys? Let's not create a list class.
Yep.
All right. Okay. Now my yeah, let's just create a yeah, include node.h, include node.
Yeah.
Okay, great. So in main, let's create a node. Oh, we want a constructor. We never created a constructor. In fact, we don't need a constructor, right? We can use a freebie constructor, or we can use a traditional. We'll do both. Okay. Just say here. Just say in main. Just say node, node, space my node, right? Space my node. Okay. Semicolon. Semicolon. Right now, at this point, the compiler would have created a node structure for you, a freebie. It gives you what is called a freebie constructor. Okay, whether this will actually compile. If you run it now, it should compile. So you can put a hello world if you want, but you don't need to, right? It should compile. It compiled, right? So no errors. Now the thing is, why did it compile? Even though you don't have a compiler, right? So in fact, let's do some getters here, right? So on the next line, you do a cout. Yeah, do a my node.get data, I think. Right? Yeah, endl. And on the next line, also my node.get. What is get next? Okay, next. And you can also tag them, saying, data equals and next pointer equals. You can say before the first left shift, you can say data equals within quotes. Yeah. And then also next equals. Right. So now that will run, and you'll actually see what got stuck into those two items. Right. There you go. So you got some random, totally junky data in there. Yeah. Because you just created a random node and you never initialized it. So this is what you get with the freebie constructor, all right? The freebie constructor that the compiler gives you just gives you space and memory. It doesn't do anything to that space. Yes? So it'll compile and run, but it's all uninitialized. So let's now refine this, right? Let's go to our random stuff because we used a freebie constructor, right? Now you can, but because people may just look at this code without watching the video. Because we use the compiler's freebie constructor. Right. On the next line, where you say, you can say, and now let's go ahead. Now we're going to go to our node.h file and define an explicit constructor, and then create another node, my node 2, right after that. So no, we'll say that in comments. So that people who are following the code will know what happened, right? So go back. So right there, put a comment there saying now we're going to switch to node.h and define an explicit constructor. Now we will go to whatever, right? We will make our own and make it call it explicit constructor, because the other one is called an implicit constructor. Right, the one the compiler gives you, it's called an implicit constructor because you don't give it, right? So it's implicitly given to you. Now node.h, and then come back and define, and then come back and define the line, what did you call the previous one? My node 2, right after that, below after that, after that. All right, right now go to your node.h. Now we can do our compiler. There you go. So you say the compiler, the constructor is node space node space node. I'm sorry. No, I'm so sorry. Open close. What do you call those things? Parentheses. Open close parentheses. Open close parentheses. A whole lot of birds in my garden today, and the reason is because I had a plastic bag with bird seed, and then Peter came yesterday and. When I was not here, and he didn't have any food, and he ripped the plastic bag to shreds, and all the bird seed is now on the grass, and all these birds are out there trying to get these bird seeds, cleaning up for me. That's really cool. Okay, all right. There you go. So we don't need any parameters. We'll just use a default constructor, right? So get rid of all of that. We'll just use a default constructor. And here we'll just say our explicit constructor is going to create a node with a 0 data item and a null pointer. All right. Our explicit constructor will create a node that is initialized. Yeah, with a zero data item, with a zero data item and a null pointer to next, right? Yeah, that's fine. Right now you can set the two values. You can set the two values explicitly. You can say data equals 0. Yeah,
I really don't like this naming. Can we do it like next node or something?
What is it not like?
No, I don't like it.
Oh, totally. Go for it. Go for it. Yeah, change it. Yeah, much better now. All right. In fact, you can even call it next P if you want, right?
That's true.
Yeah, next P. Yeah, that looks much better.
Okay. Next P. I think I got everything of it. Okay.
Yeah.
Wait, that's the wrong place.
So you can say next P equals null pointer.
Oh, wait, but we can't do that.
Hmm?
We can't do that. Our node. Oh, wait, I'm stupid.
Why can we not do that?
I was mistaking our actual setter function for this for some
Oh,
reason.
I see. Okay. All right. Now, if you run your code, you should get 0 and 0 for your data and next, right? You can even put a cout statement in your constructor, right? You can even put a cout statement in your constructor saying, hey, constructor was called, constructor was invoked, right? So go to your, constructor.
Wait, oh, shoot. It did it without us actually calling it.
It is calling it, right? But in case you want to know, you don't have to do it now, obviously, right? In case you want to know, this is what is called instrumenting a code, right? Because sometimes methods get called implicitly, like constructors and destructors. And sometimes people have logic in constructors and destructors, and they want to know when it fires off, right? When they're being called. So what they will do is put statements in these things, cout statements, to make sure they know when they're being called and stuff like that, to track, to debug. So it's called instrumenting your constructor, right? So that's what you do. Anyway, it's great. You don't have to do it. You just tell me how you do it, unless Maddie or someone asked you to do it. So everybody's okay with it, I assume. Okay, so the constructor has been invoked, and now let's also do a destructor. Let's do a destructor. Okay, so now why do we need a to your node class? Are you in a node class? Okay, great. Yeah, you are in a node class. Okay, here, you know what? We need to talk about pointers before and memory allocation. We never did that, and we started talking about nodes and pointers and linked lists. Because when it comes to destructors, I was thinking, oh, now we got to delete some memory that we allocated in a in the insert, because the constructor is not creating any item. Oh yeah, in fact, no, that's fine. This is fine. The destructor has no job, right? The destructor has no job because the constructor is not allocating memory. Is everybody in agreement with that? If the constructor allocated memory, the destructor needs to deallocate. The constructor is not allocating, and all of our allocation and deallocation is going to happen in our main, right? The main has the node, right? And it's going to allocate new nodes and link them in, and it's going to play around with the beads, create new beads and so on. So it's going to be main's job to make new beads and deallocate those beads. Yes, whoever allocates has got to deallocate, right? So I can't say I'm going to mess up this place and someone else come and clean it up. Yes, that's not fair, is it? Okay, same philosophy. We take it to programming. We say, and it keeps us, it keeps the code clean and nice and organized. Is to say that keeping things symmetrical. Because I think the human brain has some kind of affinity for form and symmetry, right? So if your program is kind of symmetric, people kind of know where to look for things, right? So people know, oh, a lot of memory is being allocated in these methods. So these methods must have a counterpart somewhere. So these are getters, setters. So something like that, right? So constructors. So then the corresponding destructors must be freeing memory. Okay, so yes, that will save later programmers who look at your code like huge amounts of time. Because they don't have to go looking for, the memory was allocated here. Let me make sure it's, because your program, some other program which uses your library might have a memory leak, right? And someone's trying to track the bug down in your code, right? And it's going to take them a lot of time. If they can say, well, is Hiram's code, which I've linked into my, 10 million line Google code base, right? So I've linked in Hiram's code. But however, after linking that code in, there's a memory leak. But there's other features too. right? So now, in order to get to the root of the memory leak, should I look into Hiram's code more, right? So when they look at your code, you want to make sure that, okay, well, there's 100,000 things you need to look at. Any one of them could be leaking memory. So I want to make sure that you're able to get past my module as quickly as you can. So that's how you can help a big company or your manager by saying, my code is going to be so easy to look at and understand, so that if there's a big problem, if there's a problem with a big system, right, I will make it as easy as possible for you to come to fix the problem as soon as possible. Meaning that you don't have to spend too much time looking at what a problem with my code, because I can show you. This is what my code does. Checked out, right? Here's a memory and allocated in constructor, destructor, right? So, but I've seen code which people don't do that, right? And the symmetry is broken, and usually bad libraries, because it's very hard to track down memory leaks in code like that. Okay, so now, is everybody okay that we're not going to do any memory allocation destructors here? If you want to make sure that you don't want to use a freebie destructor, you can actually have an explicit destructor, and then just have a cout statement saying, a destructor was called, and every time the node is destroyed, you will see the destructor being called. Okay, so you can do that if you want, but yeah. Right? Do you want to do an explicit destructor? Let's not do that. Otherwise, we can just go to main and start playing around with actual memory allocation. We'll also use that opportunity to talk about pointers, right? I have a feeling the discussion about pointers will actually spill over the same code also. We're going to take the same code and continue developing it on Thursday, right? But I have a feeling that, our discussion about pointers is going to take one more class, right? It's not going to conclude today. We'll talk about pointers, manipulating these linked structures, but it's going to spill into Thursday. What time is it now? Yeah, we've got a half hour. Yeah, but I think we still will have material to talk about. All right, good. So now let's go to main. Let's go to main. So what we want to do in main is, instead of creating, before I say we're going to allocate memory on, and a memory in a node in memory and grab the address, right? We want to know what dynamic memory allocation is, right? Is everybody here so far? Oh, maybe I need to talk about this anyway, because even though you may know it, someone else who hasn't made it to class may watch the video. Okay, so when you code your any function, there's two kinds of memory. Okay, one of them, oh, maybe that's why we should have done stacks before. Okay, all right. One of them is called automatic or immediate memory. Okay, that is inside your function, you have local variables. Yes, inside your function, you have local variables. Everybody know what a local and a global variable is? Yeah? Yeah. Okay, so inside your function, you have some local variables. Those variables are only relevant to the running function. Yes or no? Local variables are only relevant to that function inside of that curly braces. Right? If I have an int I here, that I has lost its value. It doesn't even exist after the function has ended. Yes or no?
Yep.
Okay. So technically, I could have any number of variables. I could have like 100,000 bytes allocated, many variables, vectors, all of those guys local, all of them local. So that means after the function is gone, all of those variables that were using up resources, memory, they're not alive anymore. They've died. So that space has got to be given up to the operating system. Yes or no? Or reusing those resources, right? So there's two kinds of ways in which variables are created. One is the compiler recognizes the need that you need to have immediate storage that is pertinent to you, but will actually be relevant to you only for the function that's called. And if that function exits, the function that called it has its own store of variables that will now take over and become present. So it is like a stack of plates. Okay, so that I'm afraid I have to use the same old analogy, although it's been run into the ground. Okay, it's like a stack of plates. The first function main, okay, has a whole bunch of variables, A, B, C, D, E, 5 variables. Okay, that's main, the bottom plate. The next function main calls a function. Okay, that function also has A, B, C, D, E, same name variables. But when that function uses A, B, C, D, E, you can't access main's A, B, C, D, E. It's got to access that function's A, B, C, D, E. Yes or no? Okay. All right. So now a new frame of data goes and hides main's data, so that frame of data has got its own A, B, C, D, E that lives on top of main's frame. Okay, so anytime anybody on this plane accesses A, B, C, D, E, it comes from here, not from here. Yes?
Okay.
Now assume that function calls yet another function, and that function also has A, B, C, D, E. All right? So that one's go on top of that. Right? Now, these guys, mains A, B, C, D, E, and the first functions A, B, C, D, E, are they dead and gone? Have the resources allocated to those variables, right? The resource, the 4 bytes occupied by mains A, which is an integer, right? You know that after main is finished, those 4 bytes have got to be given back to the operating system to be reused somewhere else. However, in this case, main did not die, but call some other function that took over. And while that function is running with its own copy of ABCDE, mains ABCDE, meanwhile, are not doing anything, but still cannot die. Yes? Even though they're not doing anything, they cannot die. They got to remain in a cryo state, because when that function, which has done its job, comes back, as I'm now done. My plane is gone. My ABCD is gone because they've done their job. I've got rid of them. Control is back to you. Now these guys, ABCDE, the mains ABCDE, which was lying dormant in cryo state, now got to be woken up. Now when main says ABCDE again, it's not referring to that function's ABCD, it's referring to its own ABCDE. Yes? So every time a function calls another function, right, you get a new frame of variables. That is the most recent and currently active frame of variables, but all the other frames below it cannot die. They're still there. And another property is that in order to get at any frame, you can't just pull it out. You got to make sure that, you know, when you have a stack of plates, you can't just pull out a plate, right? You got to take the last one in as the first one out. Yes? So you take the, you know, stack the plates like this, and you take them off, you take the top one off, right? Like that, like that. So these frames of variables are like stacks, right? One on top of another. Okay. Right? And then when each function dies, each function creates its own frame. So when a function dies, all right, it's no more referring to its own variables. It just really, so only when a function dies, it gives up its variables. And then the variables of the function that called it become alive, right? Woken up from cryo. So that is a very subtle step. And it's very important for function calls in general, right? We because it also kind of ties into functions and methods that we talked about before. But what happens is that when you have a variable, it can live on a frame, which means that variable is only alive as long as that frame is there. When the function dies, that frame is going to be discarded, given back to the operating system. That is called an automatic variable. And those variables are stored on what is called a stack. Because, you know, like a stack of plates, those variables are stored on the function stack, right? Main is a function, main calls another function, that calls another function. Each function has a stack, plays in the stack, right? And only the topmost function, the most recent function called, that is the only plate that's visible. Every other variable is still there in dormant cryo state. Is that okay? Are you all able to, are you in step with me? Are we cool so far? Does it make sense? Okay, now what happens if in one of your functions, you're going to create a variable, okay? Or you want to use up some resources, but those resources, you want them to be persistent until the program dies, not when your function concludes, right? You want to allocate them in main memory, not on a stack, because every function gets a stack where you can put variables, but it also has access to the heap, which is like orders of magnitude bigger than the stack, right? Many programs, functions have one megabyte of stack or something like 100 MB of stack, all right? But if you look at the memory on the computer, it may have like terabytes of memory, right? So that huge pool of memory, which every function can access, but it's not on the stack, is called a heap, right? It's called a heap of memory. It's because it's a heap of memory. So there's a heap, and when you ask for memory from the heap, you tell the operating system, hey, operating system, I want an integer, but I don't want the integer on the stack. I want an integer on the heap. Okay, there is a call in C++, right? You can say to the operating system, I want a memory item, I want an item on the heap. It will take the 4 bytes or whatever it is that is required for the integer on the heap and give you those 4 bytes. and tag those 4 bytes as saying those 4 bytes from this point onwards belong to Hiram until he releases them. Okay, so then the resource in the heap has been tagged with that program, and it's not available for anyone else until that program dies, or that program says, I'm not dead, but I don't need that memory anymore. 2 places, 2 situations in which you ask for memory from the heap and the operating system gives it to you. Or there are only 2 situations in which that memory can be released back into the general pool for other people. Okay, one is when you tell the operating system, thank you very much, sir, I don't need that anymore, I've made use of it, here you go, you can give it to someone else. Okay, that's one place. That's a good way, right? Books, you take from the library, you give it back to the library. Okay, I've read the book, I enjoyed it, I give it back. The other way is that you take the book and you don't return the book, but you die. Okay, and then the police come and clear out your home and you find the library books and return it back to the library. Okay, so 2 ways in which borrowed resources can be given back to the public or for general use. One is by dying and one is by explicitly giving it back. Yes, those are the only 2 situations in which memory that you request from the operating system will be released. Okay, the operating system will not release the memory. That is why this is the last topic we cover in CS2A, because now you're stepping outside of your home. Okay, your home is your program in your function. You're stepping outside and asking for general resources. You could be on a computer, right? You could be on a computer that has several terabytes of RAM, right? When you ask the operating system for resources from the terabytes, from the heap does not belong to you alone. The heap is a communal resource. It belongs to everyone. So when you ask for something from it, the operating system says, I'm glad to give it to you. It's not going to say, I'm not going to give it to you, right? I'm glad to give it to you. Even if I don't have as much memory as you asked for, the operating system tries its best. You know what it'll do? It'll take other programs that have asked for memory in the past, and they've got memory allocated to those other programs, and that memory is allocated to those programs, but the programs are not using them. For the last 2 hours, that memory is not being used by those other programs. So what I will do as the operating system is say, well, Hiram wants 5 megabytes of memory, but Maddie asked for 7 megabytes yesterday, and I gave it to her, and she hasn't released the 7 megabytes, however, she's not used them either. So it's just up there in memory. Now, unfortunately, because I gave Maddie 7 megabytes, I don't have 5 megabytes for Hiram. I only have 3 megabytes. So I need 2 more megabytes. I need to make 2 megabytes. So what I can do, though, is because I know that Maddie is probably asleep or sick or not working on, he doesn't want memory right now. What I'll do is take the 7 megabytes that I gave Maddie, and I'll just write to disk. I'm not going to throw it away, right? I'm just going to write it disk, on a notebook somewhere. Okay. So these are the 7 megabytes I gave to Maddie, but she doesn't seem to be around right now. She's taking a break. So I'll take that memory and give a little bit of it to Hiram, right? So that when Maddie comes back, hopefully Hiram is done with this code and I can give the memory back to her, right? Or if Hiram is not done with this code, then I can play the game by saying, okay, when Hiram's program, you can take the CPU for 50% of the time, 50% of the time, and I can take some of your memory and swap it out. So that is called taking your memory, swapping it to disk, right? That's called swap. And sometimes even C++ programs will just become slow, right? Unlike like the garbage collector in Java. I haven't told you about Java and garbage collection, right? Happens much, much more frequently in Java because the garbage collection, even C++ programs, I have seen sometimes just kick in all of a sudden, right? For no reason at all. And just going at high speed, and all of a sudden it'll just go on low speed for a couple of seconds. And then it'll pick up speed again. Some demons are programs that keep running all the time, right? So you see that. And you think, how could that happen? There's no garbage collector in C++. Why is that happening? And that, and then you do some investigation and find out, oh, it's happening because that's the point at which, someone asked for 2 extra bytes, not even like a big ass number of bytes. Someone asked for 2 extra bytes or some small number of bytes. And that triggered the operating system to say, well, you know what? I got to do some paging now. That's called paging or swapping. So when paging happens, the operating system is going to look at a lot of memory that's been allocated before, not been accessed for a long time. I'll just write it all to disk and free up that memory. So that if some person comes back and says, hey, you gave me some memory last year, right? I'm going to write into it. Then I'll say, okay, well, just wait a sec. It's on disk. I'll put it back in memory and then we can start talking. So that is a swapping or paging operation. It's not even part of CS2A, but this is essentially what happens. Does it make sense? Now, the reason I'm saying that is because there's so much memory out there programmers can get spoiled by asking for more than they actually need. Okay, so you can implement very inefficient algorithms just because you're on a big machine, you have a lot of power. No, it doesn't make sense, right? So what we need to do is make sure that not play with C++ in the spoiled kind of way that Java has trained many of us. In Java, what do we do, right? You ask for objects, in Python too, right? Ask for objects and you forget about it. You use it and then you forget about it. And you say, after my function exits, the runtime system is going to release it. It's very spoiled, right? It's like saying, I'm going to run around at home. I got a lot of candy. I'm going to eat candy and toss the wrappers all over the place, right? And someone is going to clean up after me. It may help as long as you're living a rich life, right? But what happens if you're not rich and you don't have a lot of servants following you around? So you should be set up for both situations. And so in C++, you don't have that luxury that someone also come and clean up after you, because I have seen Java code written by C++ programmers and Java code written by, I shouldn't say C++ programmers, right? More often C++, because I've seen Java code written by really good software and Java programmers. They know what's going on and they'll do the right thing. But people who don't have a good sense of how the computer does things and learn Java and do things in Java, when you look at the code, you can see them creating lots and lots of objects and just releasing them. Even when they don't have to use objects, they can use native types, right? And that really, takes a 100 mile per hour, something like that, a really fast program and slamming the brakes on it. Because the moment you step out of your stack and go into your heap, especially in Java, there's so much overhead, right? You're going to create an object, release it, create an object, release it. And, the optimizations, I don't know if it reuses the same object even, right? Many times I know that it's not even optimizing it. So so if you're in a loop that 100,000 loop things, and each time in a loop, you're creating an object, a new object or something like that, maybe in the 90,000th iteration, even though it's a small loop, a garbage collector might kick in, because in that loop you've been creating and destroying objects, right? However, someone who knows what's going on will say, no, this is a small loop, it's going to get allocated 5 million times. I'm not going to create any objects inside that loop, right? If you create a local object inside that loop and the compiler is not able to pull it out, or reuse the same object statically, right? Then you're basically screwed, because in the loop you're going to create an object, allocate, and then the garbage collector will kick in and all kinds of mess like that, right? So what we want to do essentially is make sure that we know exactly what's going on. That's why this exercise is going to help. So we'll practice first before we create an actual object. Let's practice in main, right? In main, after the two data cout items, we're going to say start a comment saying we'll practice creating memory on the heap. First, let's create an integer on the heap, right? Practice creating memory on the heap. First, let's create an integer on the heap. First, let's create an integer called, let's give it a name, right? Int p or ip or whatever you want. Int p maybe, or whatever. Yeah, call it int p, right? Now, however, it's not int p. I said int p, that's wrong, right? It's actually int star p, okay? Right, because what we're saying, and in fact, yeah, int star p. Okay, now you can put a comment there saying p is a pointer to an integer that has not yet been allocated. Okay, that is very important. People should, so it is a pointer to an integer that has not yet been allocated. It's in fact, you can cout p and run it, and you'll see p is some uninitialized value, right? You can just cout p after the int star p. Thanks. So cout p, and you'll see it's 0 or some random number, right? Because it doesn't exist right now. Why is it underlined? Why is it underlined? Why is it return underlined?
I don't know.
Oh, namespace, is it?
Oh, I think my internet must have messed up a bit. Choose my changes. Okay, that should fix it.
Okay. All right. So if you run it, it'll say 0, I think, for p, or it'll say some random value, because we haven't set it to some explicit value. Where's p? You didn't p at all. There you go. So it's some random value. In fact, if you print the contents of p, it'll print some random data and random, right? So you can, on the next line, you can say cout star p, right? Actually, you should, on the next line, you should say cout. Now say star p within parentheses. And then after the star p, put a dot. right? Now you say get data. Get, what is it? What do we call it? Get data?
Wait, but this isn't int.
P, oh, it's an integer. I'm sorry. I thought it was a node. I'm sorry.
Nope, not a node yet.
Sorry. Yeah, so star P, just fine, star P. And you don't even need parentheses now.
Okay.
So now this is the contents of that random memory location. If you run it, it'll tell us what is contained in that random memory location. And some random number.
Yay.
Okay. Now, can we change that? No, remember, this is not on our stack. It's somewhere out there, right? So can we change that value? So on the next line, so I would make a comment saying, yeah, make a comment. Yeah, thank you. Contents of P, say contents of P, contents of the memory location P, contents of memory location P. Yeah, right. Yeah. All right. So on the next line, you can say, what were we trying to do? And change the value. Yeah, let's change the value of memory location. Let's change the value of that memory location by putting the value, let's say 1729, right? Some random number, right? Pick the value, pick some number, and we want to put that value in that memory location, So what we're going to do is say star P, contents of P equals 1729, right? Or some number that you choose, right? Star P, yeah, right? So now put a comment there saying, put the value 1729 in the contents of memory address P, right? Now you can do a cout. Now you can do a cout of the contents and you will say 1729. Yeah. Not at the address of P, because P is an address comma P, right? Yes, is everybody in agreement with me? It is a subtle,
Yeah.
but
It is definitely.
right, okay. Address P. Okay. So contents of contents at P, yeah. Equals. Now if you print it again, after change, yeah. If you say star P and line, you'll see it's actually 1729. No, what's going on?
Segmentation fault.
Oh, wait. Oh, I'm so sorry. Yeah, thanks. I'm glad. All right, I'm glad we ran into this. Okay. Now it's pointing to some random location. We didn't ask the operating system to allocate memory. We just said P is a pointer to memory on the heap, but it's not pointing to a place that we asked the operating. So what we need to do before, right? Before we get to star P equals 1729. Now we're going to say, right now we're going to say, after int star P on the next line, you can say, put a comment saying blank line, and then say, put a comment saying, ask the operating system for 4 bytes to store our integer on the heap, right? Yeah. Should we say 4 bytes? Because I don't know, maybe that'll confuse. For space, let's just say for space to store it on the heap. Right? Yeah, and put that on a line by itself, and then on the next line we can allocate the memory. Okay. Then you say P equals new int, new space int. All right, that's all. Right? That's a new is an operator. It's a very important operator in C++. Okay, and you'll be using that so many times from this day until the last day you program in C++. You're going to be using new so many times, new and delete, right? Unforgettable companions. Okay, now new says, I want a new object or a new data item of this type, and that is a type. Now int, it doesn't have to be int. You can say, I want a new node, I want a new animal, I want a new this, you can say new, I want a new of anything. Okay. What the compiler will do at that time is it will exactly the same thing it's going to do. If you create it on the stack locally, it's going to do it, but it's going to do it on the heap. On memory that it is asked the operating system for, right? So if your animal is 45 bytes and you say, I want a new animal, he's going to say to the operating system, give me 45 bytes on the heap and mark it as owned by Hiram. Okay. And it's going to get 45 bytes. And in that 45 bytes, it's going to fill up your animal name, number of limbs, all those things. Yes or no? Okay, so you can say new anything. You can say, I want a new character. You want a new You can get a new anything. Okay. Now what we did there is we got a new integer. That's only 4 bytes. Is everybody okay so far? If you run it now, you won't get a segmentation fault. Okay. You won't get a segmentation fault, but it'll actually do the right thing. Right.
Yay.
Okay?
It worked.
So contents of memory location. Wait, what does it say? What's going on? Oh, after change, before and after change.
Yeah.
Oh, great. Okay. And do you know why now the before is 0? It wasn't some random value because we have the explicit construct, right? You know, every.
Right.
Oh no! This is integer. I'm talking about. I'm confusing because in your output, yeah, you have data and next, and I'm in my mind.
Oh, we can just.
Don't worry.
just-
No, don't change anything. Although someone who's watching the video, no, or looking at the code, not watching the video. All right, never mind. All right, they should come to class to get a better understanding, I think. All right. So, all right. So is everybody okay so far? Right. We created memory. Now we're going to do one thing here. Okay. Now create a function out there saying my function above main. Create a function, right? Up there saying my function, or call it void my function. Void my function. Yeah. Okay. Now in this function, no. In fact, you know what you should do is instead of let it take a parameter. I don't know. Yeah. Okay. No. Make this function return an int star, int pointer. Make this function return an int pointer. Int. Yeah. But the star should go with the function, right? Because it's not the int star is not a data type. Yeah. The function has the return value. Okay. Now here you're going to do int star p equals new p. Int star p equals new p. Right now, say star p equals 1729. Right there on the next line.
What's a p?
Oh, new int. Sorry. Sorry. All right. So you can say star p equals 1729. Right there. Okay. Now go to your main. In your main method. Oh, and then you have to return p. I'm sorry. I forgot. Return p. All right. Now go to your main. And in your main, where you did this, right? You have those 3 lines in main somewhere.
Okay, yeah.
Right?
Yeah,
So
this.
leave that there and say, we're going to try this. We're going to try, on line from 53, open a comment on line 53 saying, we're going to try the same thing by making the allocation happen inside of a function.
Oh, I think I know what'll happen now.
Oh, one sec though. Before you do that, on the previous line, you allocated new int on line 43. Now also deallocated. So the way to deallocate it on line 52, on line 51, I hit enter. And you say delete p, right? We say, we also need to deallocate. Remember to deallocate, right? So because most people, everybody knows we need to deallocate it, I think. But I think most of the time, people just forget.
Yeah.
All right. Now you say delete p. All right. Delete is a signal to the compiler saying the memory you gave me on the heap. Now you can take it and give it to someone else. Everybody okay with that? Right. Now we're going to try another experiment. We'll try this by making the allocation happen.
Wait.
You say p equals my function. P equals my function. Now you can copy and paste the cout lines, right? Before and after.
Wait. Doesn't the change happen inside the function?
Yeah. In fact, let's do this. Cut 47. Cut 47. Line 47.
Okay.
And then paste it right before the assignment on line 50. Oh, no, on line 50. On line 50.
On line 50.
50.
Yeah, okay.
No, after the comment. After the comment.
After the comment, but before 50.
Oh, I see. You want to put it before.
It's the
I want to
same.
put them 3 as a block so you can copy and paste it.
Oh, I see.
You can put it before if you want.
Like that.
Yeah. And then you can copy and paste the whole thing in that, in the second experiment.
Wait.
Except here,
Why are we doing
instead of
this?
p equals 1729, you're going to say p equals my function.
Oh, I see. Okay. I get it.
And it's not star P now, right? It's going to be P equals because it's going to return a pointer. Yeah.
Right. Yeah.
And is everything else okay? Let's change in a different way by calling a function on
Do we need to not delete P now?
No, you can delete P. I'll show you why. Right? Oh, change the comment on line 58 because I think you copied and pasted and changed the comment by calling a function. Add by calling a function now at the end of that comment.
Right.
Yeah, thanks. You can get rid of the comment, and then at the end of line 57, say comma by adding a function. By calling a function. By making it happen in a function. By making it happen inside a function. Yeah, through a function. All right, good. Now, if you run it, I think that is enough, right? You should be able to run it.
I guess just one thing though. Okay.
Oh, I see. You just want a blank line there. Cool.
Yeah.
Why? What's going on? It's not running.
Might be my internet.
Copy the whole of your code into your clipboard, just in case you reload and then it's all gone. Control A. You know, when I edit in online environments, I just got into the habit. Like, you know, when you're editing a Word document, you just get into the unconscious, subconscious habit of hitting Control S or Command S, right? Anytime you're editing, Control S, Control S, Control S. Keep on saving so you don't lose useful stuff. Like that, when I'm editing in an online editor, I usually go Control A, Command C. It always shunt it into the clipboard every 5 seconds, so that, you know, if the reload destroys everything. Because these online environments, many of them are not. So, you know, if you go to a Google Doc or something, or a Microsoft Online, right, Office 365, you can be sure that even if you're editing and the power goes out or something, you know, your code is still safe. You can go back to it and go to the library and log in. You can still access your code or whatever you're typing. But these online environments, you can't do that, right? So you're just coding like 50 lines of code and all of a sudden power goes out, gone. Well, you know, having it in your clipboard is not going to help either. Sometimes your browser crashes, right? If your browser crashes, you're screwed. Why is it still not running?
I don't know.
No, wait a sec. Go to the shell. You click on the shell tab. Yeah, up arrow. What is it? Yeah, copy that from the console. Copy that line and run it by hand. Yeah, copy that line, and then run it by hand on the shell line. You can say G++. You can just do it by G++.
It probably has it, I think.
Yeah, space -O, space main, and then just say start.cpp. It'll just get all of the CPP files. Just say space start.cpp.
Wait, but don't we need
Hmm?
node.h? Because we have nothing in node.cpp.
Start.cpp. No. So node.h is automatically included. You have a hash include.
I see. So just
CPP files, yeah.
okay.
Enter.
All
right, so now you say /main, and you should be able to run it. So that's much better than hitting the run button and hoping JavaScript will run it for you, right?
Yeah, I think the problem was that it just said connected on the right side, so I'm guessing that my connection was weird, or their connection was weird or something.
So this way, at least you know you don't have to wait for the browser.
Yeah.
All right.
We know what we're doing.
Yeah. Now here, let's try one more thing. Okay. Does everybody understand what happened just now? Now this is a bad function to write because this function, if you look at the name of the function, what is the name of the function? It's just it's some generic function. Obviously, that's a bad name, right? But even then, this function looks like it's doing something without a partner. A partner meaning I'm going to do some crazy shit here. I'm going to create a mess, but I need a partner who's going to clean up after me because I'm not cleaning up after myself, right? Anytime you make a mess, you either need to clean up yourself or you needed someone else that you've paid and arranged beforehand to come and clean up after you, right? Because otherwise people are going to get, angry with you. Yes, you go to every, place and mess things up and leave, right? It's not going to work. So this function that we wrote makes a mess because it went to the heap and created, 4 bytes of memory. It's a hole somewhere. So this is a bad function because it doesn't have a counterpart. It doesn't have a partner that's going to clean up after it. Okay, so you can put a comment. Yeah, that function creates a mess. Yeah, no, that's a great comment. Creates a mess. It creates it leaves allocated memory without without an automatic deallocation procedure put in place. Deallocation, I don't know if it's a procedure, deallocation without deallocation expected to happen. I think that's what it is, right? Without automatic deallocation expected to happen. Without automatic deallocation expected to happen. No, wait, I thought it was a good comment. Yeah. So so what we need to do on the next line, put a comment saying let's clean up for the function. Let's clean up for the function. Okay. And this is not going to happen, right? Usually we're doing this because we know that function allocated memory, we need to delete it, right? Most of the time, how do you know? You're using some third-party library, and if it allocated memory and you don't know if it allocated memory, you can't clean up after it, can you? No, right? That's why when you use third-party libraries, you got to be like super duper sure that those guys are not doing crazy things and allocating memory and leaking, right? Otherwise, you're going to spend. I've spent, right, in the past, I have spent weeks, months even, poring over my own code looking for memory leaks when the memory leak was not in my code, but it was in a library that I had unwisely, right? So that's another thing that experience gives programmers, okay? In other people's code without knowing 100% what they do, right? We tend to do a lot of that during our early programming days, right? So Python and stuff like that, there's well-known libraries like NumPy, lots of people have tried, fine. Sometimes you want to do some very custom thing, right? We want to do a very specific thing. You want a button to flash or something like that, right? That's JavaScript. It's C++, right? You want something to happen, and you say, this library, I want to use this particular prefix tree library, right? Prefix tree, very common. People use that for autocompletes. But and C++ does not give you, unlike some of the other types like stacks, lists, trees, right? C++ does not give you a native built into STL. It does not give you a prefix tree. There is a data structure called a prefix tree, which is very, very useful for creating what is called an autocomplete. Many uses. And in fact, in CS2B, right now, my CS2B students are struggling with creating a prefix tree because it's question number 8, right? So if you do my CS2B, you're going to be creating a prefix tree in question number 8. If you get to question number 8, right? So if you're going to use you're going to use someone's library, or you're going to write your own, right? But if you're writing your own, it's going to take you a day of your time. But if you're in a hurry to test your code out and you want to use someone else's library, so you're going to use someone else's library, how can you use it, right? Many people just use it, but then they may be doing. So that's the reason why we need to be really, really careful when we're using other people's code, is to be damn sure that that code does not have any bugs. Not because it is going to save you a lot of time, because the reason why we should bug-free other people's code is because of the possibility that our own code will contain bugs, right? If we know for sure that our own code is bug-free, then I don't care about using someone else's library, because if the program crashes, I know it's because of their problem, right? Because I know, okay, I need to swap that library out because my code is bug-free. I just need to get a better library. But because I am a humble person, let's say, and I'm not like overconfident in saying, okay, I never write, buggy code. My code is 100% bug-free, bulletproof code. Okay. So unless I am like that, I have to be like super duper careful in putting someone else's code into my code, because if something fails, I got to look at my own code first before I look at a library code. And if I'm going to look at my code and the bug is not in my code, I'm going to waste a lot of time and be endlessly frustrated, right? Simple bugs don't frustrate you that much, right? But big bugs, when you have to track things through a graph and so on, it's hard. Even if you have well-planned strategies, it's a pain sometimes, right? Sometimes you have to leave an experiment running for a long time to get to a particular place. That's why we need to make sure, yeah. So here we can say a delete P. We're going to delete P for that function because that function didn't clean up after itself. So you can put a comment saying, we're going to clean up after my function because my function didn't clean up after itself. Oh, you did it already. Thank you. Right now, let's go ahead to that function, to my function. We're going to try one more experiment here and say, in this experiment, we're going to say, let's call it my function 2. Let's call it my function 2. We create copy that whole thing into my function 2. All right. Now, this one is not going to allocate on the heap. It's going to say int p, int p. Okay, and semicolon after that. We don't need to, it's new is for the heap, right? So int p,
Yep.
right? Now, say p equals 1729. Now, here's the thing we're going to do. All right, we're going to return the address of our stack variable or local variable. So address p, address. Put an address sign there, ampersand. Now that is the other operator you need to know. Star is saying get the contents of that place. Address of is get me the ampersand is get me the address of it is the opposite of star. Just like log and x are opposite of each other, ampersand and star are opposites of each other. Yeah. Okay. So this says give me the address of my local variable. Now this function, according to the compiler, returns a pointer to an integer. Yes. So the compiler will not complain if you're returning a pointer to an integer. Now p, as you have done returning it like this now, is a pointer to an integer. Yes or no? Address of p is a pointer to. So the compiler technically should not complain at this point, even though you're returning a pointer to an integer, which is not correct, because that pointer is pointing to the stack, and that stack is going to be released anyway, implicitly, right? It's going to be released as soon as the closing brace, right? At the end of the function, that stack is gone. So it's going to return a pointer that is an invalid pointer. Yes? Points to the stack, and therefore it returns an invalid pointer, and therefore it returns an invalid pointer. So let's see if the compiler catches this, right? If we compile this, if the compiler is clever, it will tell us, hey, you're returning a reference to a local variable. Okay.
Are we going to change the my function to?
Oh, no, leave it there and then create another block like that and say call it my function too. Yeah.
Okay.
Right. Now, yeah, and they also on 75, you can say you got to make that say something else. Function two. Yeah. Right. Now, let's see the compiler catches that and tells us. Right. Let's see if the compiler has her back and says, hey, you're doing something dangerous. You're allocating a variable on the stack. That stack is going to be destroyed as soon as the function dies, but you're returning the address of something that lives on the stack. Yes? That's what the function is doing. Yes or no?
Yep.
Good. All right. After Maddie's sneezed.
It caught it.
Okay, good. It got it. Okay, great. What does it say?
Warning,
so
address of local variable.
yeah, okay. So the compiler caught it, right? But look at that. It's a warning. It's not a, it's check it out, right? It's so nice.
Oh yeah, it's a warning.
It's a warning, not an error, which means run it actually did delete rm dot slash main, delete rm rm, right? Type right there.
Oh.
Rm space main. Yeah. Delete it. Do an ls-l. I think you should not find the main there. Okay, now do the compilation, up arrow until you get the compilation line and then enter. Yeah, enter. Do an ls again, you should see main.
Yep.
All right, so it gave you a warning. Now, what it says is you created crappy code, man. I'm warning you, don't run it. If you run it, I'm not going to have you back. Okay, so if you run it now, let's see what happens. Segmentation fault, okay? Because the compiler told you already. The compiler told you that I'm warning you. So anything you do from now on is on your own, right? Okay, so that's what happens when we don't heed compiler warning. In fact, there is a program on Unix, not used anymore. I think 25 years ago, it was very common. It was called lint, right? Lint, because now they've taken the functionality of lint and built it into the compiler itself. The compiler itself gives you warnings like this. In the past, it didn't used to be the case, right? 25 years ago, the compiler doesn't warn you like things like this, but programmers still wanted to be warned. So they said, I'll write another program that'll be more strict than the compiler, but it's not going to do the entire compiler's job. It'll do, check for things like this. It was called lint, right? This is taking lint out of your code, jackets and things like that. So it takes these fluffs of minor errors off. Lint, and that lint was what used to run to catch errors like this. But now, fortunately, we don't have to do that. Even a compiler will tell us. So, so does everybody understand the significance of the two? I think we just find these simple experiments, but they're very, very profound in terms of the information content in these experiments that we did, right? Creating a pointer variable, heap and stack differences, and then what's the difference between a pointer to an int and pointer? They're both pointers to an int, but they're two. Even though they're pointers to an int, they're two different kinds of pointers. One of them is pointing to stack, and the other one is pointing to heap. Yeah, it's a subtle difference between the two. Many people don't do that, may understand the difference, but now we know. This experiment actually showed us the critical difference between these 2 pointers, even though they're exactly the same. Yeah, was it useful? Was this useful? Were these experiments useful to you in potentially catching bugs that you can see yourself making unwittingly, right? Because many times we're going to make these errors. We're going to constructors errors, you know. We're going to, but if you run into this once in a guided environment, then your chances are at least 50% better that you will spot the error sooner without you know, as much frustration, because you know, hey, you know, that's probably what's going on, right? And then you'll know if you have a message like this, you'll know, right? That's what's going on, and then you can see. Does it make sense? Was this useful? Okay, so what else can we do? What else can we do, right? Let's write a function three, in which it's going to allocate memory on the heap, assign the value to it. However, it's going to delete it before returning it. So in other words, it's going to allocate and deallocate here, but still delete the pointer. It's pointing to the heap, but it's memory that's been given out. Okay. You can yeah, and then you can delete, yeah, and you can delete that. Delete people. Oh, no, you can't do it after the return. Right? It's a delete p. Yeah, before that line, before the line. Oh, you have to return p after that. No, you leave the delete p and then return p, right? So
you
what
can actually do that.
is you
It seems like it wouldn't work.
Yeah, Hiram, you said something I missed.
It seems like it wouldn't work, right? It'll just return 0.
Actually, will it return 0? That's what we're going to try and find out.
I see.
Okay, so now you adjust your main also. Yeah, copy the, you know, 3. No, just copy the whole thing. Oh, no, you can delete p after there, because you know it was just memory on the stack, right?
Right. Yeah.
Right. So see out. Yeah, okay. 3. Change that to 3. Oh, no. Right now, Hiram says it's going to print the value 0, right?
Okay,
Let's see
well,
what it prints.
okay. Oh, yeah. We don't.
Oh, because you still have that function. You
Yeah,
can
yeah.
comment that line out. You can comment line 85. No, it's okay. It's just a warning.
Yeah. It's, oh shoot.
Oh, it's going to segmentation fault. It's going to.
Yeah, it's gonna segmentation fault.
Now. Oh, in fact, you should comment at all 3 lines, right? Because then we'll print the comments and not call.
Oh, yep. Okay. Try that.
Okay. Why is it?
Oh,
Oh,
it's still complaining because it still exists up here.
It's not. You can comment it out if you want, but it's not being called at all. So that's fine.
Sure, it shouldn't cause any problems. Yep, it returns 0.
Wow. To be, you know, this is not what I was thinking, right? I expected it to be 1729. Why is it?
Huh.
Why is it 0? Why? No, wait a
Because
second.
aren't we deleting p and that gets rid of?
It shouldn't. When you delete something, it doesn't go in value. My function 3. Are you calling my function 3?
Yeah, I'm calling my function 3 down there. See?
Just take that C out line. Copy that C out line.
So?
Yeah, any of those, they're the same, right? And then put it inside the function itself. No, just one line, You want one C out before the delete, one C out after the delete. Basically, what we want to see is.
I feel like it'd be faster just to type it though.
Yeah, you can just do a C out right there. Yeah, yeah, you're right, totally right. Right, one C out before the delete and one C out after the delete, saying P equals P before delete equals.
Wait, that's the point.
And ender, you need ender. That's strange.
I do need that star, right?
I'm sorry?
Do I need that star here, right? Because
Yes,
we
yes, yes.
want to.
Yes, totally. Yeah, run it now. Wow.
Yeah.
Oh, all right. So that's something new to me. Hiram, thank you so much for running this experiment. Because, I didn't know that delete would also initialize your variables for you, or things like that. You just Google and say, does C++ delete also reinitialize the variable to its default value? Does C++ delete reset variables? Does C++ delete reset? Hey, Google, does C++ delete reset variables to their default values?
I couldn't find anything related to recent verbal variables.
Hey, Google, stop. That's because I stuttered and all. So what happened? Oh, did you do that? What did you?
No, I just thought you had it.
Oh, did you type that? Type that again.
Delete reset.
Reset variables to default values. Hey, Google, does C++ delete reset variables to their default values?
Sorry, I don't have any information about that.
Hey, Google, does C++ delete clear a variable?
Sorry, I don't have any information about that.
Oh,
But I found something
yeah,
similar.
you can click that. You
Do
can
you
click
want to
that.
know how do you clear a variable in C++?
No, thank you. Yeah. This is the cost. Appointed to an object, and it does give unpredictable results.
If it's not allocated with new.
Oh, I see. That's fine. I still find it hard to believe. Okay, I find it hard to believe that delete will predictably initialize all values to default objects. Let me see if my hypothesis is the same as your hypothesis.
Can I try something? I want to try returning not the star.
No, it doesn't matter. No, that'll work, because p is just a value. It'll be copied and the address will be returned. So that's fine. It's the contents, right? It's the contents we're worried about. Yes, because
Okay, so delete only does stuff to the contents?
yeah, because the piece of paper on which you've written the address, that doesn't go away. That lives in your home.
Oh, I get it.
Yeah. Okay. So the reason why I think that delete cannot feasibly initialize objects to their default values is because it has to invoke the destructor, and the destructor is a piece of code. Now, what happens if your destructor is in fact involves logic and it has to do a lot of stuff? Then delete can be a constant time operation, right? If you have a big ass tree, 5,000 nodes or 5,000 trillion nodes, right? If you delete the tree, you can't expect the destructor to go and reset all the values. So I don't know what the hell is going on there. It should return 1729 because now it's not constant time. It was actually dependent on multiple things. It had unless what happened was when you said delete. I bet this is what happened. Okay, print the value of p, not the print. Oh, you did.
Yeah, we did that last time.
Oh, in fact, you know what, Hiram, what you did was actually a great experiment. The last, go to the end. No, at the very end. What you did, print the actual value of p. No, it wasn't a great experiment, but it could have been a great experiment, really, because what I was thinking of was here's our p, and it's pointing into memory. When you delete it, maybe it doesn't reinitialize the object, but just takes that pointer and puts it somewhere else to clear memory. That's a constant time operation, right? You allocated 5,000 bytes. You allocated a trillion bytes in location X. When you delete location X, instead of reallocating all of it, it's just going to take X and make it point to some other value where it's clear space. That's constant time, yes?
Yep.
So to test that, so that could have been a hypothesis, but that's not what's going on because the value of p hasn't changed. It's the same value.
Yep.
And obviously it can change the value, right? Because p is our local variable. It's written on a piece of paper at home. It can't come and change the piece of paper on our home saying, hey, you know what? You deleted that, so I changed the address, pointing here, not there. It can't do that anymore. So it's here. So this really is not a constant time operation in this case, right? It is not, the time taken was dependent on the size of the object. So it can't do that, I think. This would be a good question to ask. But why didn't Google answer the question? We asked Google the question, right? So delete operator, why was we should do some research. If one of you can do some research on this, saying, does the C+ delete operator also run the destructor? Well, it actually does run the destructor. It does run the destructor. Okay, so you can expect the delete operator to take time, but for native types, yeah. Yeah, I don't know why it's doing this for native types. I didn't expect you to do it anyway. Maybe it's just a nicety. Maybe it's something that's happened to C++ that I don't know, right? Maybe in the.
Oh, look, here it is. It deallocates its memory. A program that dereferences a pointer after the object is deleted can have unpredictable results or crash.
Oh, yeah, that's great. Yeah, but why is it set the value to 0 is what I'm. The reason I'm saying the reason I was puzzled was because this is a single user machine, our PC, right? No other programs are running on it. So once you delete the thing, the chances that the reason it's 0 is because as soon as you deleted it, some other program grabbed that and wrote 0 into it. That's a possibility. Yes.
I mean, what should it be?
Then, Hiram asked for 4 bytes and then Hiram deleted the 4 bytes saying, I don't need the 4 bytes anymore. Right. And then Hiram meant to do something else. But before Hiram meant to do something else, some other program, because those 4 bytes are in high demand. Right. Maddie's program said, oh, I've been asking for 4 bytes for a long time. Hiram released the 4 bytes. Let me grab that immediately and write the value 75 into it. Because that's what Maddie wanted to write. Right. Then when Hiram went and I gave up the 4 bytes, let me see what's in it. What are you going to find? 45, 75. Yes. Yes or no?
Yeah, I understand this. It's just, I'm trying to figure out why, like, deallocating memory and deleting it doesn't, like, if we go and read that location, give us 0.
I'm sorry, can you say that again?
It's like, if we delete the pointer, right, so that we deallocate the memory there, right? Why isn't it that if we look at that pointer after deallocating it, why wouldn't it be 0? Like, just with nothing else happening to it.
So I'll explain something. You tell me whether, right? You asked for a storage container on 101. Okay, they gave you a storage container.
Yep.
And then and your lease is up, and you say, I don't need this anymore. Right? What do they expect you to do? They expect you. So if your lease is up, you just turn in the keys. They're not going to go and say your lease is up, so you're going to go and throw everything out. We're going to leave everything there. And the next person who comes and takes the storage container, that's the time we're going to clean it up.
I see.
Right? So the onus is not on them to clean it up every time you delete it. Unless you trap the destructor, and every time an object is deleted, your destructor gets called and you're going to go and clean it up. Then you say that I need this container on 101, this storage space. I'm going to fill it up. And when I delete it, I'm going to clean it up and then give it to you. Because then I have my own destructor, my own cleaner upper. If you don't have your own cleaner upper, you're dependent on the system to clean it. It'll clean it whenever it wants. Only when Maddie asks for it, it's going to say, okay, you want it? I have a container on 101. Let me see if it's clean first and I'll clean it up for you. Right? So only when there's demand for it, it's going to clean it up.
I see.
Right? So there's no requirement that it needs to clean it up.
So delete doesn't actually really delete anything. It just deallocates.
It just deallocates. It says that this is not owned by Hiram anymore. It's just, anyone can go in and, the next person to ask for it can do whatever they want with it. Maybe it's still got to
write that down somewhere.
Right?
I need to write that down somewhere. Where did I first use delete? Okay.
Yeah, and does not, and it will not reinitialize the value to its default, reinitialize the variable to its default value.
It's a little too confusing. I'm just going to say it will not change.
Yeah. And then you can say, see my function 3 or experiment 3 or whatever it is within.
Well, Experiment 3 like contradicts this.
No, oh yeah. He's a experiment 3 appears to contradict this. So why could that be? You can say my function 3 appears to contradict this. Chime in on the subreddit as to why, well, reasons why this could be, right? What are the reasons this could be the case? Right? Absolutely worth extra credit, you know, in the discussion. So one reason, obviously, is that as soon as you gave it up, someone else picked it up and they wrote 0 in. Yeah. So that is the only reason I can think of, unless you can say, no, that's not the reason, because I looked at the C++ documentation. When you delete a primitive type, it's going to initialize it with 0 values. And here's the, you know, the link to that documentation. You could say that too, right? So those are possible reasons why the value would change immediately after delete, because technically the value is not supposed to change on a delete, I think, unless someone wrote into it.
Maybe I could try it on my own.
Oh yeah, this is online. Is this online?
Yeah, this is online. I could try it on my own. Wait, let me see. I have one open right now, actually.
I don't know. I don't know why it's set to 0. But yeah, because it certainly seems like a wasteful change. It's not. Yeah, that's the reason, right? It doesn't look like the C++ way of doing things. That's what I mean, right? It's setting it to 0 is not. I think it doesn't seem to me like C++, because it is unnecessary. You don't know if the programmer wants you to do that, right? They just want to free it. Why do unnecessary work, right? The whole philosophy behind C++ is that we give so much control to the user so that we don't do unnecessary work. In many other languages, things are bundled together, right? If you want to buy Windows, you also got to buy Office with it, like that, right? So in C++, you don't have to do that. You can buy each electron, not each electron. So it gives you the flexibility. You know, so in other languages, you deal with bigger blocks, right? So if you want something, you got to live with the fact that it's going to do other things too. And so that's the beauty of delete, is that it just deletes. And that's what I thought anyway. I don't know, does that all make sense? Were these experiments useful today? Because we're not going to talk about slotting a new node into the chain today. Can you, this code can be preserved, right? It's on Replit or something?
Yeah, it's on Replit. I'm trying to figure out if it'll do anything different on mine, so I'm writing it up again right now in my
great.
Linux. But it's because maybe it is a Replit thing that's going on.
Yeah. Oh my gosh, it's 10:33. Thank you so much.
Yeah, it is.
You guys don't have other classes? I know Maddie's.
I don't.
Back to bed now. Oh, this is your home office, Maddie, or something like that. Because you got another computer in the back and someone else is on it. So
Yeah, this is my home library. That's my sister.
oh, I see. Okay, cool.
Oh, it still does the exact same thing on my computer.
Hmm?
It still goes from 1729 to 0 after the delete.
Yeah, so we got to find out why it's. You know,
Yeah.
which computer is this? Is it a Linux computer?
It's a Windows subsystem for Linux.
Yeah, even
so-
Windows, they're all multitasking computers, right?
yeah.
So as soon as you take a byte and release it, a million processes running on your computer. Some other process could have grabbed the byte. Especially
Possibly,
if there's
yeah.
so many processes
It's just
running.
interesting that it's the exact same value. It's just interesting to me that it's the same value.
Well, but you can try to thwart this thing, right? One thing you can do is yeah, you can after the function has come and gone, right? P has been allocated and deleted. You can do a whole lot of stuff, you know, random computation, generate random numbers, fill vectors, dump vectors, and so on. Do lots of stuff on the heap, and then check the value of P again, right? Then you'll see the value of P has changed because you've done so
Yeah.
much stuff on the heap. It would have.
Should be. I'm just trying. I don't know why it's going to 0 if it worked as you said.
Yeah, so that's exactly. Thank you for asking that question, because it is perplexing me, and I would like to know the answer too. I would like to know the answer. So if someone could do some research online and find out why is delete without a constructor, delete of native types, not delete of objects, right? When you delete an object, it's going to call the destructor, and destructor is going to do lots of things. We want to talk about deletes of native types like character, float, double. Experiment with multiple types. Is it doing the same thing to all these types? That means when you delete something, it's doing two things. It's not just, freeing the memory, it's also reinitializing the value, which it, doesn't seem like the right thing to do. There's no utility, right? I don't see any utility in reinitializing the value. Why would it reinitialize the value? Because someone who asks for that memory again is either going to initialize it themselves. They're going to initialize it themselves. Then, yeah, it's set to 0. They're not going to blindly assume that a new just returned a value 0, unless. Yeah. What are the odds that someone is going to ask for another new integer, and that integer goes in the same place, and it's allocated, initialized to 0 now? Very low odds. I'd be surprised. Yeah. It looks like a juicy opportunity to do some research and find out what the hell is going on here, right? Because it certainly doesn't seem like the right thing to do for me. Anyway, yeah. Thank you so much, guys, for sticking around. We're just doing random experiments, but useful, relevant experiments that should help in our later adventures with C++ in this quarter. Thanks for sticking around and humoring me as usual.
Anand, I had a question.
Sure.
So I think I'm going to be taking your course next quarter. Do you have any idea what time we'd be meeting for like online meetings?
No classes, right? No. However, this is what I'm going to do. Okay. I'm thinking, I haven't concluded yet. This is what I want to do. This is an online class, right? No, you have to have lectures. However, every week I want to have a 1 hour stand-up. It's going to be not daily stand-ups like they do in companies. I want to have a weekly stand-up. Okay. Now you don't have to all be standing up, but I want to have a meeting every week in which all of you are on Zoom, and we're just going to take turns, starting from the top left to the bottom right. Everybody's just going to go and say, right, this is what I've been doing, and here's the challenge. This is where I'm stuck, right? Now we're not going to look at the solution to your problem there. You want to know where you're stuck, right? So other people can chime in later on in Reddit, Slack, hopefully not Slack and Discord, right? Other people can chime in and help you out. But we want to, a group status check every week, where I can also help out, right? I can help out at the end of the stand-up saying, well, these problems look a little hard, and this is where you can find a solution, right? So I'll help out. We'll do a startup every week, right? No formal lectures, but I'm going to expect everyone to attend these the stand-ups for participation credit.
All right.
Okay. In addition to Reddit posts, okay? Reddit posts have got to be.
Yeah. All right. Thank you. That's my question.
Right. Is that satisfactory for you? Meaning not the answer. Is that good enough section for you to enroll in?
Yeah, I think so.
Great. Okay. No, because I know some students actually say, I want to have face-to-face classes. If I don't have face-to-face classes, there's no teaching in this class. So I want.
Yeah. All right. Thank you. I'm gonna go to bed now.
Absolutely. I think you should take it easy until you get better. Hiram, thank you so much for driving. Not just today, right? You've been such a fantastic driver all along. You, Alex, all of you guys, right?
Yeah, thank you, Hiram.
Coding one step ahead, and not so much ahead that other students will be thrown away. But it's a skill to be learned, I think, and it's fantastic. It allows me to not have to pause so much to say, what should I talk about next?
Yeah.
You're already one step ahead. And talk about what you're talking about, what you're coding, which is great.
Okay. Yeah, I will put this on Reddit.
Share it on Reddit, and please do encourage or have discussions on these questions.
Yeah, especially on number 3.
Also experiments, right? Say, are there any other experiments we can run, right? And I know you guys are stretched for time. Nobody's really participating that much, but try and do this, because last week someone wrote to me and said, can you write me a recommendation for some master's program or something? And no, I don't write recommend. I make that very clear in the syllabus. But if that student had created a great profile on Reddit, right, saying, oh, these are my contributions to Reddit, I'd be more than happy to, not a recommendation, say, these are the contributions of the student. Check it out yourself. Right? An admissions officer who just Googles your name, right? And says, and oh, subreddit post by this person. Let's take a look. They say, I want that person in my class, right? So those speak like 1 million times more than a professor's recommendation. I tell you that, right? I don't value professor recommendations at all. thank you so much for coming by, and hopefully we'll, take it to the next level on Thursday.
Yeah, thank you.
Okay.
Make sure.
Bye.
Thank you, Scott. Yeah, thanks. All right,
Bye.
bye. See you later.
Goodbye. Just a second. I need to stop sharing and then I can leave. Bye.
Bye.